In the endless dark between worlds, two destinations call to us more than any others. Titan, Saturn's golden moon of methane seas, and TRAPPIST-1e, a distant Earth-like world bathed in the faint glow of a dying red sun. Both seem within reach of our imagination, yet the closer we look, the more they retreat into the impossible. Why can't we go? What stands between us and those alien shores? Like and subscribe for more journeys into the deep unknown. Tonight, we'll descend into the physics, distance, and human frailty that define the limits of exploration. Let's begin. Titan and TRAPPIST-1e are opposites, one a frozen moon within our reach, the other an exoplanet impossibly far away. Yet both ignite the same human longing, the desire to stand beneath another sky. These worlds are the twin mirrors of our imagination, one close enough to touch with robotic hands, the other so distant that its light left before modern civilization began. And yet, both beckon us with the same whisper: come see what lies beyond. Titan circles Saturn like a lantern in eternal twilight, its golden haze glowing softly in reflected sunlight. It is cold enough to turn breath into crystals and oceans into stone, yet it moves with quiet elegance through the outer dark. TRAPPIST-1e, by contrast, orbits a small red star 40 light-years away, so faint that a human standing there would see the sky perpetually bathed in dusk. Its parent star glows like an ember, old and slow, casting its warmth gently over a world that might once have been alive. These two destinations form the outer edges of humanity's reach. One at the edge of our solar system, the other at the edge of what our technology can even imagine touching. To dream of Titan is to dream of flight, of the crunch of alien sand beneath boots that have never known Earth's gravity. To dream of TRAPPIST-1e is to dream of generations, of starships built not for speed, but for patience, a legacy voyage where arrival is not a promise, but a prayer. Both dreams are built on the same foundation, curiosity wrapped in courage. Since the first telescope was turned to the heavens, we have searched for other skies to belong to. Titan, wrapped in a shroud of orange fog, is a laboratory of chemistry, a window into what Earth might have looked like before life began. TRAPPIST-1e, with its possible oceans and rocky surface, tempts us with the thought of another Earth, one that might still be waiting for us in the quiet corridors of space. But what unites these two worlds is not their similarity to us, but their indifference. Titan does not care that we dream of its methane lakes. TRAPPIST-1e does not yearn for our arrival. They exist as they have for billions of years, cold, silent, and complete. It is we who project meaning onto them. It is we who give the silence shape. When we look toward Titan, we see our past, what Earth once was. When we look toward TRAPPIST-1e, we see our future, what we might yet become. Between them lies the story of human ambition itself, a species balanced between nostalgia and hope, reaching for something it cannot hold. And yet, in that reaching, something miraculous happens. Even though we may never stand on Titan's dunes or walk the twilight shores of TRAPPIST-1e, we have already changed ourselves by imagining it. The act of dreaming, of wanting to go, has reshaped who we are. We are no longer confined to one sky. We are creatures of many suns now, defined not by where we are, but by where we long to go. Titan is the only moon with a thick atmosphere, a hazy orange world of methane rain and endless plains of hydrocarbon sand. It feels close, almost friendly, just one spacecraft ride beyond Saturn. But that illusion of nearness hides a reality as alien as anything the human imagination can conjure. Titan is not a world waiting for us. It is a world that endures perfectly without us, where familiar elements play unfamiliar roles, and where even sunlight behaves like a distant memory. For decades, scientists have called Titan a time capsule. In its chemistry, they see echoes of the early Earth, a planet before life, before oxygen, before green. Its thick atmosphere, rich in nitrogen and methane, mirrors what ours might have been billions of years ago. When sunlight filters through that haze, it triggers chemical reactions that create complex organic molecules, building blocks of life, raining softly onto dunes made of frozen hydrocarbons. It is a world caught between chemistry and biology, a place where creation is still unfinished. The Cassini spacecraft, along with its companion probe Huygens, gave us our first true glimpse beneath Titan's fog. When Huygens descended through the clouds in 2005, it fell through orange twilight for 2.5 hours, parachuting into a landscape that looked heartbreakingly familiar, rounded pebbles scattered along a riverbed, channels that curved like those carved by water on Earth. But these rivers carried not water, but liquid methane and ethane, hydrocarbons so cold they behave like water does for us. Huygens transmitted its final image as it rested on frozen sand, proof that Titan was no fantasy, but a solid, breathing world beneath the haze. Titan's atmosphere is so dense and slow-moving that a human with wings could fly there by muscle power alone. The air is thick enough to lift you gently, but toxic enough to kill you in seconds. Methane clouds drift lazily across the sky, forming weather systems that mirror Earth's hydrological cycle, but with hydrocarbons in place of water. There are lakes and seas, Ligeia Mare, Kraken Mare, bodies of liquid methane larger than the Great Lakes combined. They reflect the muted sunlight like sheets of dark glass. And beneath Titan's icy crust lies something even more intriguing. A global ocean of liquid water mixed with ammonia, kept warm by tidal forces and chemical heat. For astrobiologists, this buried ocean is a dream. It could host life unlike anything we know, creatures that breathe methane instead of oxygen, or that swim in water laced with antifreeze, insulated from the cold vacuum of space. Life that might never need sunlight, never evolve eyes, never even know a sky. If such life exists, it would change everything we know about biology. Yet even if no life stirs there, Titan remains a monument to potential, a living experiment in nature's ability to invent. It shows us that worlds do not have to resemble Earth to be rich and complex. Titan promises us not an escape, but a lesson, that life's story might be written in many alphabets, across countless forms, waiting patiently for us to learn their language. To journey to Titan is to look backward and forward at once, to see our own beginnings reflected in another sky, and to sense that perhaps, someday, humanity will return, then not as visitors, but as students, ready to listen to what this frozen world has been trying to teach us for billions of years. Orbiting a faint red star 40 light-years away, TRAPPIST-1e is roughly Earth size, with the right temperature for liquid water. But between us lies not emptiness, but a wall of time. 40 light-years, only a fraction of our galaxy, yet for us, it might as well be infinity. Every image, every spectrum of light we capture from that system is a postcard from the past, a message written when the first human radios were just beginning to hum. To reach it would mean outrunning not just distance, but the history of civilization itself. Discovered in 2017, TRAPPIST-1e quickly became a symbol of possibility, a rocky world orbiting a small, dim red star where temperatures might hover between freezing and warm enough for oceans. Along with its 6 sibling planets, it forms one of the most extraordinary planetary families ever observed. 7 Earth-sized worlds packed so closely together that if you stood on one, you could see the others as bright orbs in the sky. It is a cosmic neighborhood sculpted for wonder. TRAPPIST-1e orbits its parent star in what astronomers call the habitable zone, the narrow band, where liquid water could exist. But it does so under the light of a red dwarf, a sun that burns cool and slow, glowing not white or yellow, but crimson. The light there would never be blinding. Days would be painted in the color of embers, skies dim and deep. For any life that might exist on TRAPPIST-1e, the universe would be a perpetual sunset. Because the planet is tidally locked, one hemisphere always faces its star while the other remains in eternal night. On the day side, winds would howl from scorching brightness into endless dusk. On the night side, they'd freeze into silence. Between them, along the twilight belt where warmth and cold meet, might lie the most Earth-like region, a thin, habitable ring circling the world, where liquid oceans could shimmer beneath a ruby sky. To imagine standing there is to rewrite everything we know about sunlight. Shadows would be long and soft, colours subdued and alien. Plants, if they existed, might be black or dark red, adapted to absorb every photon from the weak crimson glow. Storms would rise in slow motion, their clouds illuminated from beneath by the red star's fire. The entire planet would breathe to the rhythm of its star's magnetic pulses, a dance of light and radiation that could last trillions of years. The allure of TRAPPIST-1e lies not just in its potential habitability, but in its permanence. Red dwarfs live unimaginably long, 10,000 times longer than our Sun. If life ever took hold there, it could persist until long after the Milky Way itself fades. TRAPPIST-1e is a promise written in endurance, a world that might still be alive when everything we know has turned to dust. And yet, we can only watch it from afar. No probe, no ship, no human mind has crossed that gap. Every photon we receive is older than our modern world, carrying secrets we can read but never touch. That distance, 40 light-years, defines both the tragedy and the beauty of our time. We have found another Earth, perhaps alive, perhaps not. But for now, it remains a reflection on the horizon of possibility, close enough to see, forever out of reach. If we travelled at the speed of our fastest probe, Voyager 1, it would take over 700,000 years to reach TRAPPIST-1e. Even Titan, just over 1 billion kilometers away, demands journeys measured in decades. The numbers sound like statistics, but they are, in truth, the walls of a cosmic prison. Each digit, each calculation, each unit of time is a quiet reminder of how small we still are compared to the scale of what we long to touch. Voyager 1, humanity's fastest emissary, drifts through interstellar space at nearly 17 kilometers per second, fast enough to cross the continental United States in 4 minutes. Yet, in the measure of interstellar travel, it crawls. In the 48 years since its launch, it has travelled only 0.002 light-years from home. TRAPPIST-1e lies 40 light-years away. Even if Voyager continued for the entire lifetime of the Sun, it would not get halfway there. Titan, by comparison, is close enough to seem tangible, yet it too defies convenience. The Cassini spacecraft, launched in 1997, took nearly 7 years to reach Saturn, threading gravity assists from Venus, Earth, and Jupiter. By the time it arrived, some of its engineers had retired. Space is not measured in distance, but in patience. Each mission is a generational act of faith, one where the results may come long after the hands that built it have turned to dust. These timescales are so vast that language fails to capture them. We are used to minutes, hours, years. Space asks us to think in millennia. Imagine leaving Earth knowing your ship will not arrive until the continents themselves have shifted, until languages have evolved, until the sky itself has changed. A voyage to TRAPPIST-1e at current speeds would span the rise and fall of civilizations, the birth of new species, the fading of constellations. To make the impossible possible, we imagine faster ways, fusion drives, antimatter engines, even solar sails riding on beams of light. Each idea shaves centuries off the journey, but none erase the fundamental truth. To reach the stars, we must first solve the energy problem. Accelerating a single ton to even 1/10 the speed of light requires the energy output of all humanity for years. The numbers grow monstrous, indifferent to our dreams. And yet, we keep dreaming. We build simulations, calculate trajectories, sketch engines that exist only in theory. The same hope that guided sailors beyond the edge of maps now drives us beyond the edge of physics. We see numbers not as barriers but as challenges, as puzzles that beg to be solved. Still, each equation whispers a truth we cannot ignore. The universe is vast, and we are young. The stars will wait for us, but not on our schedule. Titan and TRAPPIST-1e will remain as they are for eons, patient and silent, while we struggle to catch up. In the end, it's not the distances that break the dream, it's the scale of time itself. A lifetime, a civilization, a planet's history, all of it compressed into a heartbeat compared to the long, slow rhythm of the cosmos. And as we listen to that rhythm, we begin to understand that the journey is not about arriving, but about awakening to the infinite patience of the universe and to our place within its endless clockwork. Space isn't a highway, it's an ocean of frictionless silence, where velocity is earned through sacrifice and never given back. The farther we go, the slower time itself seems to help us. Distance in space is not simply about kilometers, it is about energy, patience, and endurance. It is about the cold mathematics that govern everything from starlight to spacecraft, rules that no amount of ambition can bend. On Earth, distance feels conquerable. Cars burn fuel and coast, airplanes cross oceans in hours. But in space, every meter forward is fought for. There are no brakes, no air, no friction, only gravity wells and momentum. Once you leave Earth, every gain in speed is precious and permanent, and every wrong calculation could strand you forever in the black. Imagine pushing a marble across a frozen lake. It glides endlessly, frictionless, until something, anything, stops it. That is what it means to move through the void. You can accelerate forever, if only you had the fuel. But that's the problem. Acceleration is hunger. Every fraction of velocity demands exponentially more energy. Double your speed, quadruple your fuel. Go 10 times faster, and your ship must carry not just more propellant, but propellant to push the propellant, a recursive burden that makes the dream collapse under its own weight. This is why even the smallest voyage beyond our moon demands months or years. The Cassini spacecraft took nearly a decade to reach Saturn. New Horizons, one of the fastest objects ever launched, spent 9.5 years travelling to Pluto. These are the limits imposed by physics, not by imagination. It's not unwillingness that stops us from reaching Titan or TRAPPIST-1e. It's the tyranny of distance itself, written into the universe's fabric. For travellers in space, speed is freedom, but also danger. Every increase in velocity amplifies kinetic energy. A single grain of dust, invisible and weightless at human scales, becomes a bullet when you move fast enough. At a fraction of light speed, the thinnest veil of interstellar gas could shred a spacecraft apart. To move safely, you must move slowly. To move quickly, you must accept destruction. Between those extremes lies the boundary of the possible. This tyranny is also a tyranny of time. A signal sent from Earth to a probe near Saturn takes over an hour to arrive. Commands travel through emptiness at light speed, yet feel glacial compared to the vastness they cross. To reach TRAPPIST-1e, even a beam of light, the fastest thing in existence, takes 40 years. It means that what we see through our telescopes is not the present, but the past. And so, distance becomes not just physical, but emotional. It reminds us of how fragile connection is in a universe so large. When we imagine sending a crew to Titan, we're imagining people living years behind Earth's voice. When we dream of TRAPPIST-1e, we're dreaming of messages sent to descendants who haven't yet been born. The tyranny of distance humbles us. It demands that we measure progress not in kilometers but in courage. It reminds us that the speed of light is both a gift and a boundary, a cosmic speed limit that ensures the universe will always remain larger than our reach. And perhaps that is the point. If space were easy, it would not feel sacred. The struggle to cross it is what gives meaning to the journey. The act of trying, against all odds, to touch what was never meant to be touched. In that struggle, humanity finds its truest reflection, small, determined, and endlessly reaching into the dark. Before reaching Titan, a spacecraft must weave through Saturn's radiation belts and the shifting gravity of its icy moons, each orbit a ballet choreographed by invisible mathematics. Every motion, every turn, every burn of fuel must be calculated years in advance, long before the spacecraft ever feels the faint pull of the ringed planet's gravity. To journey to Titan is not a straight line. It's a descent into a cosmic maze, one that moves and reshapes itself as you approach. From afar, Saturn glows like a golden lantern, serene and steady. But up close, it is a world of chaos and harmony in equal measure. Its rings are not solid sheets, but countless billions of fragments, ice, dust, and stone, dancing to the rhythm of gravity. Each ring is a frozen symphony, shaped by the silent pull of Saturn's many moons. Together they create ripples, gaps, and waves that echo through the system like music. To pass through them safely requires not just engineering but elegance, a machine guided by patience through a storm of mathematics. The Cassini spacecraft spent 13 years within Saturn's realm, orbiting through this labyrinth of beauty and danger. Each maneuver had to account for dozens of forces at once: the drag of ionized gas, the resonance of distant moons, the tug of Saturn's magnetosphere. To the casual eye, it was just an orbit. To mission control, it was a dance with gravity itself. Cassini's flight path resembled a looping calligraphy of physics, each curve written in units of speed, distance, and destiny. The radiation belts around Saturn hum with invisible energy, particles trapped by magnetic fields that swirl like invisible storms. For a human, they would be instantly lethal. For a spacecraft, they are an endurance trial. Electronics must be shielded, sensors hardened, systems built to survive what would tear most circuits apart. And still, every journey through that space is a gamble, a test of whether our fragile machines can withstand the same forces that shape planets. Saturn's moons complicate everything further. Dozens of them orbit in nested, shifting paths, tugging at one another like dancers exchanging hands. Some, like Enceladus, spray plumes of ice and water into space, creating clouds of particles that drag against spacecraft like faint winds. Others, like Mimas and Rhea, pull and release in rhythmic cycles, subtly altering trajectories. The entire system is alive, moving, breathing, changing, and every spacecraft that enters must learn to move with it, not against it. And yet, within that chaos lies grace. Cassini learned to use those very moons to its advantage, stealing momentum from them in gravitational slingshots that allowed it to soar from orbit to orbit. It surfed the invisible curves of gravity like a cosmic surfer, each pass calculated down to fractions of a second. The result was a journey so precise that it became poetry, a testament to how well we've learned to listen to the universe's hidden rhythms. Only by mastering this dance can we reach Titan, Saturn's largest moon, the jewel at the heart of the labyrinth. To get there, we must surrender to Saturn's pull, to its gravity wells and orbital harmonies, to its music of motion. Each trajectory, each thrust, each pause is not just navigation, it's trust. Trust that our equations can decode the language of the cosmos, and that our machines can move through it with grace. When at last a spacecraft breaks free of the final orbital curve and Titan fills its view, a soft orange marble half hidden in shadow, it feels less like a rival and more like revelation. To reach Titan is to understand Saturn, not as a planet, but as an entire ecosystem of motion, a shimmering labyrinth of physics and beauty intertwined. It is the universe's way of reminding us that every destination worth reaching first demands learning the steps of the cosmic dance that guards it. At -290 degrees Fahrenheit, Titan's air is so cold that oxygen would shatter like glass. Methane replaces water, and rain falls in liquid hydrocarbons, alien weather under an amber sky. It is a place where the familiar has been rearranged, where what is liquid here would be rock there, and what we breathe as air would fall as snow. Titan's atmosphere moves slowly, dense as oil, whispering through plains of frozen dunes that stretch for hundreds of miles. Everything there, sky, wind, sea, exists in slow motion, like a dream unfolding at the edge of time. Standing on Titan's surface, would feel like standing in the aftermath of creation. The horizon would glow with a dim orange haze, sunlight scattered and softened into a permanent twilight. The sun, 10 times farther away than from Earth, would appear as no more than a brilliant star, barely strong enough to cast shadows. The air would press against your suit with the weight of thick fog, a mix of nitrogen and methane so cold it could liquefy oxygen. Even sound behaves differently there, muffled, syrupy, as if the world itself were exhaling in slow, frozen sighs. Titan's cold is not the cold of emptiness, it is the cold of chemistry. Methane, ethane, and ammonia flow where water cannot. Lakes and seas shimmer like black glass, their waves sluggish and heavy, their shores carved not by erosion but by cycles of freezing and thawing hydrocarbons. In this place, what we think of as weather takes on another meaning. Clouds form from methane vapor, condensing into rain that drizzles onto icy dunes. It's a cycle almost identical to Earth's, but made of alien ingredients. A mirror image of our own planet, replayed in a darker key. And yet, within this stillness, there is movement. As Saturn orbits the Sun, Titan tilts with it, causing subtle variations in temperature that stir its skies. Winds gather strength along the equator, sculpting dunes hundreds of meters tall. When methane storms sweep through the atmosphere, they fall with quiet ferocity, filling dry basins and carving channels into the frozen crust. For a few tangent days, each one 16 Earth days long, the landscape changes, alive with motion beneath its frozen breath. Cassini's instruments once recorded reflections off Titan's lakes, sunlight glinting off the surface of Kraken Mare, the largest known sea there. It was a shimmering moment of proof that liquid existed beyond Earth, not just as ice, but as a body that could move, reflect, and dream. Scientists called it a specular reflection, but to those who saw it, it was poetry, a distant glimmer that said, "We are not alone in having oceans." Beneath Titan's frozen crust, there lies more mystery. An ocean of water mixed with ammonia, liquid not because of heat, but pressure, extends for hundreds of kilometers below the surface. That ocean may be ancient, stable, and potentially habitable. If life exists there, it would not resemble ours. It might breathe chemicals, metabolize hydrocarbons, or move through water so thick and dark it has never seen light. Titan's frozen breath is both invitation and warning. It tells us that the universe can create familiar patterns in utterly unfamiliar ways, that life, chemistry, and beauty can emerge even in worlds of ice and darkness. Here, cold is not death. It is preservation. The same chill that freezes methane into lakes could also preserve the secrets of life for billions of years. To stand beneath Titan's amber sky would be to see a reflection of our own world in a colder mirror. It would remind us that warmth is not the only cradle for life, and that the breath of creation moves even through frozen air. Titan is not lifeless, it is simply asleep, waiting for us to listen closely enough to hear it breathing. Titan's thick orange haze blocks sunlight completely. Only radar can pierce it, revealing vast dune fields and seas of methane. Strangely familiar, yet utterly lifeless. As we drift closer, the dunes stretch like golden oceans frozen in motion, rippling in patterns sculpted by winds we cannot feel. Every grain of sand seems to carry a secret, each ridge a whisper of eons-long processes that shaped this alien landscape far from Earth's warmth. The air, heavy with nitrogen, carries a scent we cannot breathe, a weight so tangible that even in imagination, it presses gently against our senses. Beneath that dense sky, liquid methane forms lakes that reflect nothing but the dim amber light filtering through the clouds. Waves shimmer subtly, moved by winds colder than any winter on Earth, brushing along shores that have never known life as we understand it. Strange rivers carve paths through frozen plains, winding silently under skies so thick that the sun is a pale ghost. A faint memory of the light we take for granted. In the stillness, the moon feels both immense and fragile, a world apart, suspended in an eternal twilight that feels like a dream we almost remember. Yet Titan is not entirely silent. Methane rain falls sporadically, striking the surface with a hollow, echoing rhythm. Clouds drift lazily, shifting shapes over continents that are vast and empty. Radar scans reveal mountains made of ice, rising like frozen sculptures, their surfaces etched with fractures that hint at subterranean oceans moving far beneath. Here, the ground is not solid rock, but a living, breathing mixture of ice and chemicals, a strange playground for physics that has no equivalent on Earth. Flying across Titan, one can imagine the quiet patience of this world, the slow churn of geological time stretching over millions of years. Craters lie untouched, dunes migrate imperceptibly, and the seas of methane swell and shrink with the seasons. Tides driven not by the sun but by Saturn's pull, a cosmic rhythm that beats quietly in the distance. In these movements, there is both chaos and order, a harmony that feels almost alive, though no living thing will ever witness it. Even in imagination, the horizon is endless. Titan's orange sky curves around the globe, unbroken, and every shadow hides a story we cannot read. Here, light and matter conspire to create landscapes that are hauntingly familiar. Shorelines, waves, mountains, but rendered strange, a reminder that life is not the only form of beauty. The moon teaches patience, the art of observing without interfering, of understanding the subtle dance of elements and forces. As we drift away, the haze thickens, swallowing the seas and dunes once more. Titan fades into a quiet glow behind layers of clouds, leaving only the memory of a world that is alive in its silence, alive in its rhythms, yet untouched by life as we know it. The sky hides the ground, and in doing so, it preserves the wonder of mystery, inviting our minds to wander, to dream, and to marvel at the secrets held in the amber shadows of a world far, far away. Reaching Titan isn't a landing, it's a drift through molasses. Parachutes open into thick atmosphere, instruments freeze, and time itself seems to slow to a whisper. Every movement is deliberate, as if the world itself insists on patience. The dense nitrogen clouds wrap around the descent module, muffling sound and blurring vision, leaving only the gentle vibration of progress against the ship. It feels less like motion and more like being suspended in a dream, carried by invisible currents across a landscape both familiar and impossibly strange. Below, the orange haze shifts and dances with the faintest glimmers of sunlight that penetrate the thick atmosphere. Shadows stretch long across dune fields, their shapes changing subtly as the craft drifts closer. Lakes of liquid methane appear like polished mirrors, reflecting the dim light in wavering patterns that ripple without a breeze. The module's instruments detect minute changes in surface composition, revealing waves, shorelines, and ice formations that suggest a slow, relentless cycle of tides and winds, movements so gradual that they seem eternal to a human mind accustomed to urgency. The atmosphere itself resists the descent. Dense and viscous, it pushes against the module as though the air itself is a living barrier. Temperature plummets, frost creeps across sensors, and yet, paradoxically, there is a serenity in this resistance. Every second stretches into 100, every motion a measured step in a cosmic ballet. Saturn's distant rings shine faintly through gaps in the clouds, reminding us of the wider celestial stage on which Titan performs its quiet, measured dance. Time dilates not just mechanically, but perceptually. From the window, the horizon curves in a way that feels impossible, a gentle swell of terrain that challenges notions of distance. Mountains of ice rise like frozen waves, while dunes undulate in patterns that mimic desert seas. The seas of methane glisten faintly, their surfaces disturbed only by slow-moving currents and subtle tidal effects. Even as the module descends, there is no hurry, no urgency, only the patient unfolding of a world in motion at its own pace. As the module drifts ever closer to the surface, the sounds of descent are surreal. The parachutes whisper against the atmosphere, instruments hum in delicate resonance, and the module itself seems to inhale with the pulse of Titan. There is no crash, no sudden arrival, only a slow embrace, a gradual merging with a world that has existed for eons in quiet majesty. Time here feels elastic, stretching to accommodate both the enormity of distance and the delicacy of approach. Finally, the module hovers just above the liquid methane seas. Reflections ripple faintly, capturing the dim light and the orange haze above. The dance is completed, yet it feels less like an end and more like a beginning, an invitation to explore, to drift, to witness a world that moves not in hours or days, but in the slow, hypnotic rhythm of a universe entirely its own. Here, in the stillness and the cold, the slow dance of arrival reminds us that the journey is as profound as the destination, and that sometimes patience is the most intimate way to meet a distant world. On Titan, you could strap on wings and fly. Its gravity is only 1/7 of Earth's, yet its air is dense enough to lift you with each breath of movement. Imagine stepping off a dune and feeling yourself glide effortlessly, as though the moon itself has grown gentle beneath your feet. Every motion is amplified. A leap becomes a flight, a flutter becomes a glide. The thick, nitrogen-rich atmosphere cradles you, wrapping around your body like a soft, invisible current, inviting exploration in a way that Earth's familiar pull never could. The surface stretches endlessly, a mosaic of textures and colors filtered through the amber haze. Golden dunes roll like frozen waves, their grains whispering against each other under the faint, diffused sunlight. Between them lie patches of ice, jagged and glassy, shimmering like shards of a frozen ocean. Methane lakes reflect the muted sky, still and undisturbed, offering the illusion of calm amidst a world of hidden motion. Each step, each flight, is a dance with gravity and atmosphere, an intimate conversation with the laws of physics that govern this alien land. Flying across Titan, you notice subtleties that escape the eye on Earth. A gentle puff of wind can carry you meters higher. A shallow dive lets you skim across methane lakes, sending ripples that vanish almost instantly. The interplay of weight and lift turns even simple movements into poetry. The horizon curves softly, a reminder that you are on a smaller world, one where the scale of the sky is both intimate and infinite. Mountains of ice rise in jagged clusters, dwarfed by the sweeping plains around them, yet monumental in their silent majesty. Titan's gravity is a teacher of patience and precision. Even with reduced pull, the dense air resists sudden movements, demanding grace. Every flap of wings, every shift in balance, is a negotiation with the moon's subtle forces. You learn to drift with the currents, to anticipate the gentle rise and fall of the air, to become a part of the landscape rather than an intruder. Flying here is not just movement, it is a meditation, a slow immersion in a world that feels both tangible and dreamlike, a place where physical limits expand to meet imagination. The seas of methane glint with muted light as you soar above them, reflecting the orange sky and fractured ice cliffs at their edges. You notice patterns in the waves, delicate currents guided by Titan's own subtle rhythms. Winds shift imperceptibly, lifting you higher without effort, turning each flight into a dialogue with the moon itself. Every glance downward reveals a new texture, a new rhythm, a reminder that this world has been sculpted by forces older than memory. Here, on a moon far from Earth, the ordinary becomes extraordinary. Breathing feels different, lighter, yet tethered by the dense atmosphere that surrounds you. Flight is effortless, yet profound, a reminder that gravity is not a constraint but an invitation. Titan teaches that worlds can move differently, that the simple act of rising above the ground can open new ways of perceiving space, time, and self. And as you glide through amber skies, wings catching currents invisible to the eye, you realize that exploration is not merely a journey across distance, but an awakening to the subtle forces that shape every world, every motion, and every dream. Beneath Titan's frozen crust lies a global ocean of liquid water mixed with ammonia, a possible cradle for alien life, locked away beneath miles of ice. The surface, with its amber haze and frozen dunes, is only the quiet mask of a restless world below. Imagine a layer of ice thick enough to bury mountains, yet beneath it, water flows in dark, unseen currents, swirling with energy and the faint warmth of tidal forces. Here, hidden from sunlight, chemistry dances quietly, molecules colliding in slow, deliberate rhythms that could, in the right conditions, spark the earliest stirrings of life. This ocean is vast, stretching across the moon like a hidden sea beneath the surface of an alien planet. Its depth is measured in tens of kilometers, a liquid layer insulated by ice and sustained by the gravitational tug-of-war with Saturn and neighboring moons. Tides ripple beneath the crust, gentle yet persistent, shaping the hidden seafloor in ways that may mirror processes on Earth. Hydrothermal vents might spew warmth and nutrients, tiny oases in a world otherwise sealed from the light, where life, if it exists, would thrive in darkness, unseen but vibrant. The ice above is not uniform. Fractures, ridges, and occasional cryovolcanoes hint at the ocean's restless presence, evidence that this moon is not inert but dynamic. Each fissure is a potential window into the liquid world below, a subtle invitation to imagine what moves there. Perhaps currents swirl with patterns yet to be understood, or chemicals mix in cycles that could sustain ecosystems unlike anything we know. Even without direct observation, the physics of Titan assures us that beneath its frozen exterior, the ocean is alive with motion, a slow, constant heartbeat hidden from view. Floating above in orbit, or descending slowly through the orange haze, one can sense the contrast between surface and depth. The dunes and methane lakes seem silent, eternal, and unchanging, while below, the ocean pulses with potential. The interplay of heat and pressure, ice and liquid, creates an environment that is at once alien and familiar, a reminder that life, if it arises, is clever and persistent, finding ways to exist even in the strangest corners of the cosmos. Titan's hidden ocean is a meditation on patience and possibility. It challenges our expectations of habitability, stretching the imagination to consider that life need not rely on sunlight, warmth, or the oxygen we cherish. Instead, it may thrive in chemical gradients, in tides and pressure, in darkness, punctuated only by the slow glow of hydrothermal activity. To consider it is to widen the definition of what a living world can be, to embrace the vast diversity of the universe's hidden niches. As we drift away from Titan, the thought of this concealed ocean lingers. A silent world beneath a silent world. Miles of ice separate us from the mysteries below, yet the possibility of life, strange and patient, remains. The hidden ocean is a reminder that the universe often hides its most profound wonders beneath surfaces we cannot immediately see, inviting explorers, dreamers, and thinkers to imagine, to wonder, and to hope. In its quiet darkness, Titan whispers a secret of resilience, of potential, and of the hidden rhythms that might, somewhere beneath the ice, hum with life itself. When methane rains, it doesn't nurture, it erodes. Rivers of liquid gas carve valleys through solid ice, sculpting a geology that behaves like slow, breathing stone. Unlike water on Earth, methane does not bring life. It reshapes landscapes with quiet persistence, its flow guided by gravity and the contours of Titan's frozen crust. Each drop is a sculptor, each stream a slow-motion artist painting the surface in muted amber tones, leaving behind grooves, channels, and basins that tell the story of a world in constant, imperceptible change. The rain falls in gentle sheets or sporadic bursts, and when it lands, it hisses faintly against the icy surface, evaporating or pooling in shallow lakes. These lakes ripple under faint, alien winds, their currents almost imperceptible, yet over millennia, they carve mountains and valleys that dwarf anything human hands could create. Titan's rivers are patient, unhurried by our perception of time. Channels twist and meander like veins in a frozen body, carrying methane from highlands to seas, shaping coastlines that shimmer under the dim, filtered sunlight of an orange sky. Methane erosion creates a world that feels alive, yet lifeless, a paradox that fascinates and unnerves. Valleys deepen imperceptibly, cliffs erode into jagged perfection, and plains stretch vast and smooth, all as if the moon itself breathes slowly through a geological heartbeat. Hydrocarbons accumulate in lowlands, forming dark, viscous pools that glint with faint reflections, while hills and ridges resist the persistent caress of liquid methane. Observing these features from above, one can see a topography in motion, a world that grows, shifts, and sculpts itself without the presence of biology. The chemistry of Titan's rain is a delicate balance of extremes. Methane, ethane, and nitrogen interact with the icy surface in reactions both subtle and profound. Soluble compounds are carried downstream, depositing new layers in some regions while stripping others bare. In the dim amber light, this chemistry manifests as faint coloration in dunes, glinting shores along methane lakes, and thin films of frost where evaporation leaves residues. Every drop is a tiny experiment, a reminder that even lifeless worlds follow laws of physics and chemistry that create landscapes as complex and intricate as any ecosystem on Earth. Flying above the surface, the rivers and valleys reveal patterns that mirror those on Earth, yet rendered strange by alien proportions, compositions, and flows. There is an eerie familiarity in these forms, a sense that some fundamental principles of fluid dynamics are universal, yet the materials and temperatures transform them into something entirely otherworldly. The rain sculpts not just the land, but our understanding of what a planet, or moon, can be, inviting contemplation of the extraordinary variety of geological processes across the cosmos. As the orange haze thickens and Titan's slow storms drift past, the mind settles into a quiet wonder. Each droplet of methane is a sculptor, each river a patient artist, shaping a silent world with deliberate care. In watching the alien rain, one glimpses the hidden rhythms of a moon where life may not exist, yet beauty and transformation persist. Titan teaches that erosion can be art, chemistry can be choreography, and even in a lifeless world, motion itself can feel alive. Sunlight at Saturn's distance is 100 times weaker than on Earth. Solar panels die in the dark, nuclear batteries fade, energy becomes the most precious resource in the outer system. Every device, every probe, every light flickers with careful conservation, as if the universe itself demands restraint. In this frozen, distant expanse, power is not merely a convenience, it is survival, a thread connecting human ambition to the stark reality of cosmic isolation. The sun, once a blazing furnace at the center of our sky, is now a dim, amber glow, barely brushing the horizon of Titan. Photons drift lazily across billions of kilometers, and when they arrive, they are weak whispers of the energy we take for granted on Earth. Solar panels, optimized for abundance, struggle to convert these faint rays into usable electricity. Every watt becomes precious, carefully rationed to keep instruments alive, heaters functioning, and communications open across the void. Here, energy management is an art as much as a science, a delicate dance between scarcity and necessity. Nuclear batteries offer a measure of independence, yet even these are finite. Radioactive decay provides warmth and electricity, but slowly, inexorably, the power diminishes. Mission planners must account for the slow fading, scheduling experiments and movements to match the steady drain. A spacecraft hovering above Titan is alive only as long as energy flows. Without it, instruments freeze, computers sleep, and the world falls silent beneath the amber haze. Energy is the lifeblood of exploration, the invisible tether that allows us to touch moons and rings light years away from Earth. This scarcity transforms how we interact with these distant worlds. Every maneuver is weighed, every experiment measured. We cannot afford exuberance. Curiosity must be tempered by practicality. Yet there is a strange poetry in this constraint. It teaches patience, careful observation, and ingenuity. Engineers design systems that recycle heat, capture every stray photon, and use energy only when necessary. In this frigid expanse, survival is not brute force but elegance, the ability to do more with less, to stretch the invisible threads of power across impossibly long distances and icy landscapes. On Titan, even natural energy is subtle. Winds move the thick atmosphere, tides pull at methane seas, yet harnessing these forces is a challenge. The sun's warmth cannot melt ice, and chemical gradients are slow and cold. In this silence, humans and machines alike are forced to think small, slow, precise. Every joule becomes a story of ingenuity, every functioning instrument a triumph over distance, darkness, and indifference. As you imagine drifting above frozen plains and methane lakes, consider the quiet hum of energy powering exploration, the soft glow of instruments scanning dunes, the faint heat keeping sensors alive, the radio pulses escaping through the orange haze back to Earth. In a place where sunlight is a ghost and nuclear batteries fade, the power problem becomes a lesson in patience, a meditation on scarcity, and a reminder that even in the outer reaches of our solar system, life, or the machinery that extends our curiosity, persists through cleverness, perseverance, and an intimate respect for the invisible currents of energy that flow through every corner of the cosmos. Radio signals from Titan take over an hour to reach Earth. From TRAPPIST-1e, they would take 80 years, an echo that would outlive its sender. In the vast expanse of space, distance is measured not just in kilometers, but in time itself. Every message, every signal, becomes a ghost journeying across the void, carrying intentions, questions, and discoveries at the speed of light, yet always arriving long after the moment it was sent. To communicate in the outer solar system is to learn patience on a cosmic scale, to understand that immediacy is impossible, and that every answer will always come too late. Imagine sending a signal from Titan, a world cloaked in orange haze, its methane lakes shimmering faintly under filtered sunlight. The message leaves a spacecraft hovering above frozen dunes, a pulse of energy carrying data, images, and sound. It races toward Earth at 299,792 kilometers per second. Yet even at this unimaginable speed, it takes 1 hour and 7 minutes to traverse the distance. By the time it reaches us, Titan has already rotated, the landscape has shifted, and the moment captured by the transmission exists only as a memory, a snapshot frozen in time, divorced from the now of both sender and receiver. Across the universe, the delay becomes more extreme. TRAPPIST-1e, orbiting a distant star nearly 40 light-years away, represents an almost unimaginable separation. A radio signal sent from its surface today would arrive on Earth 40 years from now, and the reply another 40 years later. Humanity would converse with the distant exoplanet in echoes, a dialogue stretching across decades, perhaps outlasting those who first initiated it. Every exchange becomes an exercise in foresight, a meditation on the slow, relentless march of light through darkness, and a reminder that time is as much a barrier as distance in the cosmic theatre. This delay reshapes exploration itself. Decisions must be made autonomously by machines and humans alike. Spacecraft cannot wait for instructions. They must navigate, measure, and adapt independently. Even thought, filtered through technology, must consider the long lag between intention and reception. The silence between transmissions is not empty. It is full of anticipation, reflection, and the faint hum of signals racing through nothingness, bridging worlds, yet never truly bringing them together in real time. The communication delay also transforms our perception of presence. Seeing Titan's dunes or TRAPPIST-1e's skies through transmitted signals is like watching a memory unfold rather than witnessing an event. The universe becomes a layered landscape of past moments, each arrival a story from yesterday, last century, or millennia ago. Even light from distant stars is history, yet in that history lies beauty, persistence, and connection. As you drift in imagination, consider the long, patient journey of each message. An image of Titan's methane lakes travels through space like a quiet traveler, a solitary pulse of information carrying the essence of a distant world. In every delayed reply, In every echo that may never return, there is a lesson. The cosmos is vast, indifferent, and majestic, teaching us to listen, wait, and cherish the fragile threads that connect minds and worlds across time. In the quiet of the void, communication becomes not a convenience, but a meditation. A slow, luminous conversation with the universe itself. To reach another star in a human lifetime, a ship must travel close to light speed. But at such velocity, a single dust grain would strike with the force of a bomb. Every particle in the void, invisible and tiny, becomes a devastating threat when your motion approaches the cosmic speed limit. The universe, which feels empty from a distance, suddenly turns into a storm of potential destruction, where even the faintest mote carries the energy of catastrophe. Imagine a spacecraft accelerating toward Proxima Centauri. At a fraction of light speed, collisions with space dust generate heat and radiation intense enough to damage hulls and fry electronics. Shields would glow, ablaze from the friction of impacts, not unlike the fiery streaks of meteors burning through Earth's atmosphere, but magnified 1,000-fold. Protection is not a matter of choice but survival. Every gram of shielding weighs against fuel, design, and the limits of engineering. The faster you go, the more violent even emptiness becomes. Yet there is another dimension to speed. Time begins to stretch differently for those aboard the ship. Close to light speed, hours outside may be years for travelers, while seconds inside feel like minutes. The universe itself becomes elastic, bending around the ship, compressing distance and dilating experience. But no amount of relativistic trickery can spare the vessel from the heat and energy of collisions. Every journey, no matter how theoretically possible, carries the risk that the smallest fragment will strike with unthinkable force. Even the vast emptiness of interstellar space is not truly empty. Cosmic dust drifts silently, relics of exploded stars, remnants of ancient galaxies, and microscopic particles of ice and rock. At near light speed, these tiny travelers become lethal. The craft must anticipate impacts long before they occur, deflecting, absorbing, or evading them with technologies that exist only in imagination. Navigation becomes a dialogue with the invisible, a careful dance where precision and foresight are not luxuries, but the difference between life and obliteration. The psychological weight is also immense. Imagine moving through darkness at unimaginable speeds, knowing that every grain of cosmic dust, every rogue particle, could end the journey in a fraction of a heartbeat. Yet the beauty of the endeavor remains undeniable. Stars rush past in compressed brilliance, nebulae stretch like rivers of color, and the mind perceives the universe in ways that earthbound observers cannot imagine. The impossible heat of speed is both threat and revelation, danger and awe, reminding travelers that the cosmos rewards courage and ingenuity, but only when respect for its laws is absolute. In this dance of velocity, matter, and energy, we confront limits not just of technology, but of imagination. To approach the stars is to face heat, radiation, and cosmic projectiles that would obliterate the unprepared. And yet, even in the face of such impossible challenges, the dream persists. To traverse the darkness, to glimpse other suns, to feel the exhilaration of motion at the edge of reality itself. The impossible heat of speed is a meditation on fragility and daring, a reminder that the universe tests every ambition with fire, and that true exploration requires reverence for both beauty and danger. Every kilometer per second of acceleration demands fuel that weighs more than the ship itself. To reach relativistic speeds, you'd need more mass in fuel than exists in our solar system. The dream of interstellar travel collides with a harsh, immutable reality. Energy is heavy, and mass cannot be conjured. For every push forward, there is a proportional burden, a chain of weight that stretches beyond imagination. Even in the emptiness of space, the tyranny of mass reminds us that moving faster is not just a matter of desire, it is a calculation, a ledger of cosmic expense that grows exponentially with ambition. Picture a vessel designed to carry humans to Alpha Centauri. To accelerate to a tenth of light speed, the fuel alone might dwarf entire planets. Hydrogen, antimatter, fusion, each promising tremendous energy, yet each limited by its own supply, containment, and logistics. As the ship begins its journey, a small fraction of mass is converted into propulsion, but the rest remains a ballast, a reminder of the cost of motion. The ship does not soar freely. It drags the weight of possibility behind it, every gram a testament to the physics that govern the universe. Even if technology could somehow improve, the limits remain stubborn. Rockets obey the rocket equation, a simple yet cruel truth. To go faster, you need exponentially more fuel. Every additional increment of speed is not linear but geometric, each push demanding not just more energy, but more matter to deliver that energy. The dream of a near light-speed journey encounters a wall of numbers and mass, a challenge that is at once mathematical and profoundly poetic. It is a reminder that space is vast, and the tools we carry are finite, tethering human ambition to the cold arithmetic of the cosmos. This weight is not just physical, it is symbolic. Fuel represents preparation, patience, and the consequences of every choice. In the imagination, we picture ships gliding effortlessly between stars, but the reality is a careful negotiation with scarcity and inertia. Even advanced propulsion methods, from nuclear fusion to hypothetical antimatter engines, cannot escape the fundamental requirement. Energy must come from somewhere, and wherever it comes from, it has mass. In this truth lies both limitation and beauty. The universe challenges us to innovate, to reason, and to understand the delicate balance of force, motion, and consequence. Yet there is a meditative rhythm in the calculation. Each kilogram of fuel, each incremental speed, each equation of motion becomes part of a cosmic choreography. The weight of fuel teaches patience, humility, and awe. It reminds us that the distance between stars is not measured merely in light years, but in effort, resources, and understanding. Even as we dream of journeys that defy imagination, we are tethered to the finite, grounded by the mass that must move with us, carrying both possibility and limitation through the silent depths of interstellar space. In the end, the weight of fuel is a quiet meditation on ambition and restraint. It illustrates that in the dance of acceleration and distance, nothing is free, and everything comes at a cost. To travel fast is to carry the burden of possibility itself, a lesson written in kilograms, equations, and the silent, unyielding laws of the cosmos. At near light speed, time slows for the traveler, but not for those left behind. A trip to TRAPPIST-1e could be one lifetime aboard and 40,000 years back home. Imagine stepping onto a vessel, engines humming with energy, accelerating toward the stars. Inside, seconds stretch, days pass in slow motion, and the familiar cadence of life continues almost as if nothing has changed. Yet outside, Earth turns, civilizations rise and fall, continents drift, and millennia sweep by in the blink of an eye. The traveler moves forward, but the world they know races away, leaving a gap measured not in distance, but in the inexorable flow of time. This is the paradox of near light speed travel. Motion becomes a distortion not just of space, but of experience. The universe bends around the ship, compressing light and stretching seconds into hours, days into decades. From within, the journey feels tangible, immediate, intimate. Yet each signal sent home, each thought of those left behind, is delayed across epochs. Letters, messages, memories, all arrive to a world utterly transformed, a reality unrecognizable from the departure. The traveler becomes both participant and observer, suspended in a river whose currents run in conflicting directions. The trap is subtle but profound. As speed increases, the traveler gains access to faraway stars, yet loses the familiar march of shared time. Friends, family, entire cultures may vanish in the span of a single human lifetime, while the traveler ages slowly, insulated by the relativity of motion. Moments of joy, curiosity, and wonder are preserved aboard, yet they exist in isolation, echoes of a universe moving on without them. Every mile traversed brings both discovery and estrangement, a duality that is as beautiful as it is tragic. Even science itself bends under the weight of this temporal distortion. Observations of distant worlds are seen in accelerated or delayed perspectives, phenomena that unfold in what feels like minutes for the traveler, but centuries outside. Stars flare, supernovae ignite, and entire galaxies rotate. Yet the traveler experiences these events on a compressed or stretched timescale. The universe becomes a living canvas, its motions readable yet alien, its rhythms intimate yet detached. The trap of time transforms exploration into a meditation on perception itself. And yet, there is a strange serenity in this distortion. The traveler learns patience not as a virtue, but as necessity. Moments of reflection stretch into lifetimes. The mind, freed from the tyranny of normal clocks, drifts in thought, observation, and imagination. To move fast is also to slow down, to witness the cosmos in a way inaccessible to those bound to ordinary time. Here, isolation is not merely loneliness, it is an opportunity to see the universe as it stretches across both space and temporal dimensions, to understand the fragile interplay between motion, aging, and observation. In this trap of time, the cosmos reminds us that speed and distance are inseparable from experience. To journey among the stars is to confront the gulf between our own perception and the relentless passage of history. And yet, in that gulf lies wonder, the chance to witness the universe in ways few will ever understand, to age differently, to exist between moments, and to move through the cosmos suspended between eternity and a single lifetime. Cosmic radiation, micrometeoroids, and decades of isolation would break the human body long before any engine would. Space is not kind to biology. Our cells, evolved under the gentle shielding of Earth's atmosphere and magnetic field, are delicate instruments, easily disrupted by high-energy particles that streak through the void. A single solar flare can bathe a spacecraft in invisible fire, altering DNA, damaging tissue, and reminding us that life, as we know it, is fragile, even in the protective cocoon of engineered habitats. Micrometeoroids add a constant, silent threat. Tiny as dust, yet moving at tens of kilometers per second, each collision carries more energy than a bullet, puncturing shields and threatening the delicate systems that sustain life. Outside the relative safety of a spacecraft, even a single miscalculated maneuver could turn the cosmos into a storm of destruction. Inside, the walls offer protection, yet every impact reverberates in subtle ways. Tiny vibrations, microfractures, reminders that space is not empty, but filled with motion, hazard, and invisible energy. Time, too, takes its toll. Decades of isolation and weightlessness reshape the human body. Bones lose density, muscles atrophy, fluids redistribute, and the senses adjust to conditions alien to Earth. Psychological strain compounds the physical challenge. Solitude stretches days into months, months into years, and the mind begins to inhabit a different rhythm, one dictated by the slow pulse of life in artificial gravity, recycled air, and limited stimuli. Even the strongest will feel the subtle erosion of self, a quiet reminder that the human body and mind are products of a specific world, exquisitely tuned to its conditions. Radiation, motion, and isolation together create a fragility that no amount of engineering can fully erase. Spacesuits and habitats offer defense, shielding, and artificial gravity, nutrition, and medicine. Yet every measure is provisional, a temporary barrier against relentless forces. The human body is like a candle in a storm, bright, vulnerable, and astonishingly alive, yet dependent on constant attention, protection, and care. Even minor errors, overlooked hazards, or prolonged exposure could result in cascading consequences, highlighting the precariousness of life beyond Earth. Yet within this fragility lies a paradoxical beauty. The human body, delicate and transient, becomes a measure of courage and resilience. Each heartbeat, each breath, is an act of defiance against a universe that does not bend to our needs. Movement, observation, and thought aboard a starship becomes sacred rituals, each small success a triumph over conditions that would extinguish life instantly without preparation. The fragility of flesh reminds us that exploration is not merely a technical challenge, but an intimate dance with mortality, endurance, and the limits of our design. In the silence of deep space, the fragility of flesh is both warning and meditation. It teaches reverence for our biology, respect for the cosmic forces we cannot control, and awe for the sheer audacity of life, daring to persist where conditions are hostile beyond imagining. To travel among the stars is to exist in a state of exquisite tension, where every organ, cell, and thought carries the weight of survival, and every movement is a quiet victory in the unforgiving theatre of the cosmos. Even if a craft could make the journey, its systems would need to operate flawlessly for centuries. A single spark, a frozen valve, and the mission dies in silence. There is no rescue, no repair, no chance to call for help across light years. The spacecraft must be alive in its own way, self-maintaining, vigilant, and tireless, enduring conditions that would crush any unprepared machine. Every circuit, every motor, every pipeline becomes a thread in a web of survival, and the failure of one strand could unravel the entire mission. Imagine floating among the stars aboard such a vessel. Its engines hum with quiet authority, systems cycling endlessly, sensors scanning for threats invisible to the human eye. Cooling systems pump fluids across radiators, fuel valves open and close with precision, and computers monitor millions of variables simultaneously. The ship becomes a living organism in miniature, its heartbeat the rhythm of data and energy flowing through engineered veins. It never sleeps, yet it also never tires. Its consciousness, if we may call it that, is a careful balance of logic, redundancy, and self-preservation. Time stretches infinitely for the craft, each day identical in its demands. Centuries pass, as if measured in hours, and yet every instant counts. A minute-long glitch could freeze a valve, clog a fuel line, or misalign a sensor, imperceptible at first, but capable of cascading into total failure. The ship exists in a delicate tension between order and entropy, a marvel of engineering pressed against the unyielding laws of physics. It teaches patience and respect, reminding us that longevity in space is not given, it is earned through design, foresight, and relentless vigilance. The dangers are subtle as well as dramatic. Cosmic rays bombard circuitry, slowly degrading materials. Micrometeoroids pierce shields, leaving tiny fractures that grow with time. Thermal cycles expand and contract components, while dust and ice drift across external surfaces, unpredictable and merciless. Inside, systems must compensate automatically, adjusting flow, temperature, and power, correcting imperfections that arise over decades or centuries. Every movement, every calculation, every pulse of energy is part of a continuous struggle against decay, a quiet war against time itself. Yet in this relentless operation lies a strange beauty. The ship embodies continuity, persistence, and patience. It is a monument to human ambition and ingenuity, a vessel carrying the dreams of explorers across incomprehensible distances. Its flawless operation is not merely mechanical, but almost poetic, the harmony of countless systems working in silent synchrony, a symphony of engineering against the indifferent void. The ship becomes a guardian of knowledge, a witness to distant stars, a sentinel that never rests, never ages, and never falters. To imagine such a craft is to confront both fragility and resilience. In its endless vigilance, it mirrors the very nature of life in the cosmos, tenuous yet persistent, delicate yet astonishingly capable, reliant on balance and precision, yet capable of extraordinary endurance. The ship that never sleeps reminds us that in the vast silence of space, survival is not a momentary act, but a continuous miracle, woven through centuries of quiet, unyielding vigilance. Some dream of transforming Titan's atmosphere into something breathable, but to warm it even a few degrees would require more energy than the sun delivers to Earth. The methane lakes, frozen dunes, and thick orange haze are not merely obstacles, they are vast, indifferent forces, resisting change with a patience that dwarfs human ambition. Even the most advanced technologies could at best scratch the surface, nudging temperatures or compositions only infinitesimally, while the moon itself would remain overwhelmingly alien. Imagine standing beneath Titan's hazy sky, imagining blue air and flowing water, trees swaying in gentle breezes. It is a vision both beautiful and impossible. To alter the climate of this world, one would need to flood it with energy, massive orbital mirrors to redirect sunlight, immense fusion reactors, or chemical reactions on a planetary scale. Every plan becomes an arithmetic of impossibility, where the quantities required outstrip not only human engineering, but the very resources of the solar system. Dreams of terraforming fade against the stark scale of physics. Even if we could somehow supply the energy, the consequences remain unpredictable. Titan's thick nitrogen atmosphere, its methane cycle, and icy crust interact in ways that are delicate and poorly understood. Change one parameter, and the ecosystem, such as it exists, could destabilize. Lakes might evaporate too quickly, dunes could shift violently, and the chemistry of the surface could create clouds of toxic compounds. The illusion of control reminds us that worlds are not canvases, and nature is not a palette waiting for human artistry. Titan resists, patiently and immovably, preserving its identity against the impatience of ambition. There is also a quiet lesson in the impossibility. Terraforming is seductive because it promises familiarity, the comfort of an Earth-like environment in the alien. Yet Titan's current state holds beauty of a different order. Frozen seas that ripple with methane, dunes sculpted by winds over eons, and skies that glow in amber twilight. Its alienness is not a flaw, but a feature. A reminder that the universe contains landscapes that exist on their own terms, indifferent to our desires. To appreciate Titan fully is to accept its boundaries, to see its grandeur without trying to reshape it. Even the faintest change would require decades, centuries, or millennia. And still, the scale of energy dwarfs our civilization. Sunlight weakly filters through the haze, a reminder that even the most basic warmth is precious. The moon teaches humility. Ambition is admirable, but awe is essential. To contemplate terraforming is to dream, but to understand the impossibility is to awaken to the immensity of Titan, the patience of physics, and the elegance of worlds that endure without human intervention. In the end, the illusion of terraforming is a meditation on scale, power, and respect. Titan is a teacher of restraint, showing that even with imagination and technology, some forces are beyond our reach. And yet, in that impossibility lies wonder, a world preserved in amber, a place untouched, unchangeable, and sublime, inviting us to observe, reflect, and marvel at the quiet persistence of a universe that will continue on its own terms long after our dreams fade. Titan's orange glow is a reflection of chemistry, methane absorbing light, creating an endless twilight that no human eye could ever adjust to. The atmosphere filters the sun into a soft amber haze, bathing dunes, lakes, and ice cliffs in a dreamlike sepia. Shadows stretch unnaturally long, light scatters in ways unfamiliar, and even the brightest glints on the methane seas are muted, softened, rendered otherworldly. It is a glow that belongs entirely to Titan, an illumination born from molecules dancing in the sky, indifferent to earthly notions of day or night. Imagine floating above the moon in a silent craft. The surface below shimmers with muted contrasts, the golden dunes punctuated by dark, viscous methane lakes that reflect the dim, diffused light. Mountains of ice rise like frozen sculptures, and in every valley and ridge, the chemistry of the air casts the world in perpetual dusk. Your eyes strain, slowly adjusting, but they cannot fully reconcile with this alien glow. Colors familiar on Earth vanish or twist into new, strange forms. Even the concept of brightness seems stretched, softened, and rearranged by Titan's thick atmosphere. Methane is both artist and veil. It absorbs and scatters sunlight, altering perception, and yet it does more than obscure. It defines the world. The orange sky is a mirror of molecular interactions, an endless ballet of photons bouncing, bending, and being absorbed. This chemistry sculpts light as surely as winds sculpt dunes or rivers carve valleys. Titan's twilight is not simply a dimmed reflection of the sun, it is a phenomenon created by the moon itself, a constant reminder that alien landscapes follow rules entirely their own. From a distance, Titan glows like a lantern in the darkness of Saturn's realm. The methane mirror reflects faint sunlight across the rings, sending gentle amber light to neighboring moons and distant observers. It is a subtle broadcast, a signal of the chemical complexity and quiet dynamism hidden within this frozen world. To witness it is to perceive the interplay of light, gas, and surface in slow, deliberate rhythms, a meditation on processes invisible to human senses, yet breathtaking in their consequences. Beneath this chemical glow, the landscape continues its quiet transformation. Rivers of methane-etched valleys, dunes shift imperceptibly, and frozen plains expand or contract with temperature fluctuations. All of it is lit by a sky sculpted in amber, a light that changes gradually with no sunrise or sunset as we know it, a permanent twilight that reminds any observer of the strangeness of perception and the universality of physical law. Titan's methane mirror is more than a visual phenomenon. It is a lesson in patience, perception, and humility. It teaches that beauty does not require familiarity, that a world can captivate even when its light confounds us. The orange glow invites contemplation, to drift above its dunes, to gaze at lakes under an alien sky, and to marvel at the artistry of chemistry playing across an entire world. Here, light itself becomes alien, and yet, in its strangeness, utterly mesmerizing. Unlike Titan, TRAPPIST-1e orbits a dim red star that glows eternally at sunset. Its days and nights are one side of the same face, tidally locked forever. One hemisphere basks in unending light, the other shrouded in perpetual shadow, and the line between them, the terminator, is a soft twilight zone where temperatures are mild and winds circulate gently. The world spins slowly, almost imperceptibly, yet the pull of gravity and the relentless hold of its star govern every movement, every breath, every potential life. Imagine standing at the edge of that twilight, where warmth and cold meet. To your left, the star hangs low, casting faint red light across jagged plains, glinting off mineral deposits and frozen lakes that never fully melt. To your right, night stretches endlessly, a black canvas pierced only by distant stars and the faint reflection of light from the sunlit hemisphere. The air, thin or thick depending on local composition, holds the slow circulation of winds tracing patterns dictated by the eternal day-night divide. Here, the planet breathes, though in rhythms alien and deliberate, and the gravity beneath your feet is steady, silent, a constant reminder that you are anchored to a world unlike any on Earth. Tidal locking brings strange consequences. Oceans, if they exist, pool on the warmer side or freeze into ice on the dark side. Atmospheres shift, carrying heat and particles around the globe, generating weather systems that are slow, patient, and relentless. Storms do not erupt suddenly, but drift along invisible currents, sculpting landscapes with careful persistence. The surface itself is a balance between extremes, molten or soft rock on the sunlit side, crystalline ice, or frozen regolith on the shadowed side, and in between, a thin ribbon of habitability, where temperatures might allow liquid water and, perhaps, life to endure. The gravity of TRAPPIST-1e is silent but unyielding. It tethers everything to the planet, guiding water, wind, and dust across vast distances, shaping valleys, ridges, and plains. It governs the circulation of gases, the rise of winds, and the gentle ebb of tides under a red sun. To move across this world is to feel a pull both familiar and strange, lighter or heavier depending on location, yet always steady, an invisible hand sculpting every motion. travelers would feel anchored yet free, as though the world itself conspires to keep them present in the eternal rhythm of its spin or lack thereof. Time here is also peculiar. Days never end, nights never arrive. The planet presents the same face to its star eternally, and yet observers in the Terminator Zone experience the slow, almost hypnotic progression of light as heat and atmosphere interact. Shadows drift subtly, clouds move lazily, and the red glow above hints at the power of a star far dimmer than the sun, yet no less commanding. TRAPPIST-1e's silent gravity is both a cradle and a challenge. A reminder that worlds beyond our solar system live by rules simultaneously alien and rigorous. It teaches that stability can be eternal, that extremes can coexist, and that beauty can emerge not in movement, but in stillness, in the quiet balance between light and dark, heat and cold, gravity and freedom. To stand there is to witness a planet breathing in silence, eternal twilight stretching infinitely, a world suspended in its own patient rhythm, inviting contemplation, wonder, and awe. Under a crimson sky, photosynthesis might still happen, but slower, sluggish life breathing light that never burns bright, only smoulders. The red star of TRAPPIST-1e casts a muted glow, gentle yet persistent, painting every surface in deep shades of garnet and rust. Sunlight here is faint and filtered, lacking the brilliance of Earth's sun, yet sufficient to drive slow, deliberate chemical reactions. Life, if it exists, must adapt to this dim rhythm, growing in patience rather than speed, thriving in endurance rather than abundance. Imagine standing in the Terminator Zone, the thin ribbon of twilight between day and night. Plants, or their alien analogues, stretch slowly toward the red sun, leaves absorbing long wavelength photons with exquisite efficiency. Photosynthesis is a languid process, a dance measured not in minutes but in hours or days. Growth is quiet, almost imperceptible, yet persistent. Life here has learned to savor the faint light, converting it into energy with deliberate precision, each molecule a testament to resilience and adaptation. The crimson illumination transforms perception. Shadows are softer, edges blurred, colors shift into unfamiliar tones of deep red, brown, and maroon. The world seems slower, more deliberate, as if time itself has been tempered by the red sun's gentle energy. Rivers of molten or semi-liquid materials reflect the muted light, sending back a glow that is subtle yet pervasive, bathing the landscape in a warmth that is comforting and alien at once. Even the sky itself is alive with chemistry, suspended gases filtering and scattering light in ways that render every sunrise, or its eternal approximation, unique, haunting, and hypnotic. Under this subdued radiance, ecosystems, if they exist, would evolve with patience. Photosynthetic life would need to maximize efficiency, storing energy carefully, conserving resources, and waiting for every photon. Predator and prey, if present, would follow rhythms dictated by the slow pace of chemical and thermal cycles. Survival depends on ingenuity in form and function, slow metabolisms, steady growth, and careful orchestration of every biological process. The red sun sets the tempo of life, teaching organisms to endure rather than to rush. There is a poetry in this slow illumination. Life under a red star would not burn fiercely. It would smoulder, like embers glowing softly in a long, unbroken night. Each leaf, each stalk, each microbe captures light that is precious and fleeting, transforming it into the quiet persistence of existence. The crimson glow is not oppressive, it is meditative, encouraging observation, reflection, and respect for the subtle rhythms that sustain alien life. TRAPPIST-1e's red sun teaches that brightness is not always necessary for beauty or survival. Even dim light, filtered through alien atmospheres, can nurture growth, sustain life, and create wonder. To stand under this sun is to witness endurance in slow motion, to see the universe adapting to extremes, and to understand that even faint light, when persistent, can illuminate entire worlds, giving rise to life that is patient, resilient, and profoundly strange. TRAPPIST-1e's eternal twilight drives colossal winds, rushing from day to night in ceaseless motion, a planetary heartbeat sculpted by physics. On this tidally locked world, the sunlit hemisphere bakes under persistent crimson light, while the dark side remains frozen in shadow. The extreme temperature contrast sets air in motion, generating gusts that roar across valleys, sweep over ridges, and spiral around mountains, carrying heat, dust, and clouds in an unending, invisible river. The winds are not chaotic, they are a measured, rhythmic pulse, a natural circulation system dictated by the star's unyielding gaze and the planet's silent rotation. Imagine standing in the Terminator Zone, the thin band where eternal day meets eternal night. A gentle breeze here might feel like a whisper, but it is the edge of a system of planetary-scale currents. Higher above, winds race faster, sculpting clouds and dust into patterns that span thousands of kilometers. The air carries heat from the burning day side toward the frozen night, creating a balance that stabilizes temperatures in the narrow habitable band. Every gust, every eddy, is part of a complex, ceaseless motion, a dynamic equilibrium maintained over millennia by nothing but sunlight, gravity, and the immutable laws of physics. The winds shape everything. If there are liquid pools, they ripple under their touch. Dust and sand accumulate along ridges, valleys, and plains, forming subtle dunes that migrate slowly across the surface. Clouds drift in bands, their shadows stretching across the Terminator, moving steadily as if the planet itself breathes. Even the quietest moment carries energy, a faint vibration in the crust, a subtle change in pressure, a reminder that this world is never truly still. The winds are the heartbeat of TRAPPIST-1e, persistent and invisible, an eternal motion that reminds any observer of the scale and majesty of planetary processes. Life, if it exists, must coexist with this ceaseless motion. Slow-growing plants or alien analogues might anchor themselves against the gusts, developing resilience and form to withstand constant atmospheric sculpting. Creatures, if present, might ride thermal currents, using wind as a conveyor, adapting to perpetual motion rather than resisting it. The winds dictate rhythm, movement, and opportunity, an invisible hand guiding evolution, shaping ecosystems, and orchestrating the tempo of life across the twilight band. From orbit, the planet would appear alive. Bands of clouds streak across its surface, dust patterns shimmer in faint red light, and the ceaseless circulation of atmosphere reflects a world in motion. There is a hypnotic beauty in the continuity. No sunrises, no sunsets, only the eternal flow of energy, from light to dark, a persistent reminder that physics can create elegance without intention, order without consciousness. TRAPPIST-1e's winds teach patience and awe. They reveal that even in worlds far from Earth, where days and nights are unchanging, the planet breathes, moves, and persists. They are the silent heartbeat of an alien world, sculpting, circulating, and enduring, inviting contemplation of forces both immense and invisible, and reminding us that motion itself can be as mesmerizing as light, warmth, or life. If oceans exist there, they shimmer beneath a half-lit sky, where starlight never truly fades. A world that dreams in red, never waking, never sleeping. On TRAPPIST-1e, the oceans, or seas of unknown liquid, collect and hold the planet's heat, circulating warmth from the sunlit hemisphere toward the frozen night side. Their surfaces ripple under the ceaseless winds, reflecting the crimson light of the eternal sun in soft, shifting patterns. Shadows and light blend into a continuous, muted dance, creating a landscape both alien and hauntingly beautiful. Imagine standing at the edge of a darkened coastline, the red twilight spilling gently across waters that are neither fully illuminated nor completely hidden. Waves lap silently, carrying dissolved minerals and perhaps even the faint traces of life, moving in rhythms dictated by gravitational tugs and atmospheric currents. In this twilight zone, Time seems suspended, the ocean moves endlessly, yet slowly, a patient witness to the unchanging relationship between day and night, heat and cold, light and shadow. The chemistry of these hidden oceans may differ entirely from Earth's. Salts, ammonia, or other exotic compounds could keep them liquid under conditions where water would freeze solid. Their surfaces might reflect light differently, shimmering in hues of deep crimson, garnet, or copper, faintly glowing with biochemistry or energy trapped in the liquid itself. Every ripple is a story of physics in motion, an eternal conversation between energy, gravity, and matter. Even in darkness, the ocean is alive with subtle currents and interactions, moving in ways invisible to the eye, yet profoundly shaping the world around it. Above, the sky never darkens fully. TRAPPIST-1e's red sun hangs low, bathing the landscape in constant twilight, while distant stars punctuate the shadowed hemisphere, offering pinpricks of white light against the dusky red. The oceans reflect this faint starlight, creating a mirror of the universe above and below, a quiet bridge between celestial infinity and planetary intimacy. Observing this shimmer is like watching a world dream, slow, deliberate, and without consciousness, yet full of motion and life's potential. Even on the night side, beneath frozen surfaces, oceans might circulate heat and nutrients, creating environments that could harbor life. Strange and resilient, currents flow gently, powered by gravity and planetary rotation, moving unseen under layers of ice or exotic liquids. The oceans are a secret, a hidden world where chemistry and energy continue in silence, indifferent to human observation, yet quietly sustaining processes that echo the rhythms of life itself. TRAPPIST-1e's oceans teach patience, perspective, and wonder. They exist in a balance of extremes, heat and cold, light and darkness, wind and calm. To observe them is to confront the alien poetry of a world that never sleeps, never wakes, but moves in ceaseless, gentle rhythms. Their shimmer is a meditation on the persistence of nature, the quiet beauty of alien chemistry, and the enduring possibility of life in forms we cannot yet imagine. The ocean in the dark is not merely liquid, it is memory, motion, and reflection, holding the heartbeat of a planet that dreams eternally in red. Every breath there would be poison. Carbon dioxide too thick, oxygen too thin, a suffocating mix where survival means engineering a world from scratch. TRAPPIST-1e's air is not a gentle medium for life. It is a reminder that habitability is rare, and that planets exist on their own terms. To humans, every inhalation would carry slow danger, invisible yet relentless, filling lungs with gases that support neither biology nor comfort. The atmosphere itself is a ghost, present, moving, shaping the environment, yet indifferent to life as we know it. Imagine standing on a twilight plain, the red sun low on the horizon, winds sweeping across rocky ridges. The air swirls, heavy with carbon dioxide, carrying dust and exotic aerosols. Each molecule is part of a planetary system older than humanity, circulating in endless rhythms, absorbing heat, reacting chemically, and sculpting clouds and weather patterns. The air moves without malice, yet it is deadly, dense enough to weigh upon the body, sparse enough in oxygen to make every breath a struggle. Even the faintest exhalation feels like a negotiation with an invisible, unyielding force. To survive here would require engineering on an unprecedented scale. Habitats would need to be sealed, air scrubbed and balanced, pressure maintained against the relentless pull of gravity and winds. Life support systems would filter, oxygenate, and circulate gas continuously, protecting against a ghostly enemy that is everywhere yet unseen. Even a minor failure, an unbalanced valve, a malfunctioning scrubber, could turn the suffocating mix from a manageable inconvenience into an instant threat. The atmosphere of TRAPPIST-1e is a silent teacher, reminding explorers that survival in the cosmos is never passive. It is a constant, deliberate act of creation, care, and vigilance. Yet the ghostly atmosphere is more than threat. It is the essence of the world itself. It drives the ceaseless winds, sculpts clouds, shapes temperature extremes, and transfers energy from day to night. It interacts with oceans, surfaces, and possibly life in ways subtle and profound. Every storm, every dust swirl, every faint cloud pattern is written in the composition of this alien air. To study it, to understand it, is to witness a planet breathing on its own terms, in a cadence older than any human civilization. There is a stark poetry in its danger. Humanity's ingenuity is measured against this invisible force. Life as we know it cannot exist without intervention. Yet the atmosphere is a canvas for imagination, engineering, and perseverance. Habitats, pressurized suits, artificial ecosystems, they are all responses to this unseen challenge, attempts to impose order upon an indifferent environment. TRAPPIST-1e's Ghost of Atmosphere teaches humility. It is the quiet presence of a world that exists regardless of our ambitions, demanding respect and careful planning. To survive, we must listen, adapt, and create, acknowledging that life in alien skies is always provisional, fragile, and remarkable. The air itself whispers a lesson, that the universe is full of worlds that breathe, move, and endure. Indifferent to us, yet full of wonder for those patient enough to understand. Even with fusion drives or antimatter engines, the energy to reach TRAPPIST-1e would rival the sun's total output for an entire second, unimaginable but precise. The scale is almost incomprehensible. To accelerate a ship to a fraction of light speed, to carry humans or instruments safely across tens of trillions of kilometers, requires energy so vast that it challenges every assumption about feasibility. Every equation, every calculation, is a reminder that interstellar travel is not simply a technological problem, it is a confrontation with the raw arithmetic of the cosmos. Imagine a vessel poised at the edge of our solar system, engines primed to ignite. Even the most efficient fusion reactions produce only a fraction of what is needed. Antimatter could deliver far more, yet containment, production, and safety turn every gram into a delicate dance of precision. Every joule of energy is accounted for. Every inefficiency could cost decades or centuries of travel. To reach TRAPPIST-1e, humanity would need to harness energy on scales that rival entire stars, if only for an instant, and direct it with exacting control over mass, thrust, and trajectory. The Great Energy Barrier is both literal and symbolic. It represents the immutable limitations of physics and engineering, a wall measured not in materials but in power and scale. It forces the mind to expand, to imagine not just propulsion, but civilization-wide mobilization, energy collection on planetary or stellar scales, megastructures harvesting light or fusion, and systems capable of converting that energy into controlled acceleration. Even in theory, every approach highlights a profound truth. The universe is vast, and motion across its expanse is never free. Yet there is an elegance to this constraint. The barrier quantifies ambition, translating dreams into precise terms. It asks explorers to consider not only distance, but cost, efficiency, and consequence. A ship accelerating toward TRAPPIST-1e is more than metal and fuel. It is a manifestation of human ingenuity grappling with absolute limits. Its journey becomes a meditation on energy, scale, and patience, an understanding that travel is not merely a matter of desire, but of respecting the profound magnitude of the cosmos. Even the smallest calculations matter. A tiny misalignment, a fractional miscalculation in thrust or fuel distribution could multiply across decades of travel, rendering the journey impossible. The universe does not forgive errors at this scale. Precision is survival. The energy required is not just immense, it is unforgiving, a reminder that every star, every planet, every particle obeys immutable laws, and that ambition must contend with reality, no matter how brilliant the imagination. The Great Energy Barrier also reframes time and perception. While travelers might experience months or years, the universe outside continues relentlessly, indifferent to their motion. The energy needed to traverse the distance is intertwined with the scale of time and space itself, linking acceleration, mass, and relativistic effects into a single, awe-inspiring constraint. To witness or calculate it is to glimpse the magnitude of the cosmos, and to understand that even the faintest star hides energy beyond comprehension. TRAPPIST-1e's distance is more than spatial. It is an arithmetic of impossibility and aspiration. The Great Energy Barrier teaches humility, patience, and awe. To contemplate it is to recognize the vastness of the universe, the limits of power, and the extraordinary scale of ambition required to cross the void. In that impossibility lies wonder, a measure of how immense, precise, and unyielding the cosmos truly is. Even with fusion drives or antimatter engines, the energy to reach TRAPPIST-1e would rival the sun's total output for an entire second, unimaginable, yet precise. The scale is almost incomprehensible. To accelerate a ship to a fraction of light speed, carrying humans or instruments safely across tens of trillions of kilometers, demands energy so vast it challenges every assumption about feasibility. Each equation, each calculation, is a reminder that interstellar travel is not merely a technological problem, it is a confrontation with the raw arithmetic of the cosmos. Imagine a vessel poised at the edge of our solar system, engines humming in readiness. Even the most efficient fusion reactions provide only a fraction of what is needed. Antimatter offers far more potential energy, yet containment, production, and safety turn every gram into a delicate dance of precision. Every joule must be accounted for, every inefficiency magnified over decades or centuries of travel. To reach TRAPPIST-1e, humanity would need to harness energy on scales rivaling entire stars, if only for an instant, and direct it with exacting control over mass, thrust, and trajectory. The Great Energy Barrier is both literal and symbolic. It embodies the immutable limitations of physics and engineering, a wall measured not in materials, but in sheer power. It forces imagination to expand beyond engines and hulls, to envision civilization-wide mobilization. Orbital collectors gathering stellar light, fusion networks spanning worlds, megastructures channeling energy with near-perfect efficiency. Even in theory, every approach illuminates a profound truth. The universe is vast, and motion across its expanse is never free. Yet within this constraint lies a quiet elegance. The barrier quantifies ambition, translating dreams into precise, almost poetic terms. It asks explorers to consider distance, cost, efficiency, and consequence simultaneously. A ship accelerating toward TRAPPIST-1e is more than metal and fuel, it is human ingenuity grappling with absolute limits. Its journey becomes a meditation on energy, scale, and patience, an understanding that travel is not merely desire made physical, but a dialogue with the enormity of the cosmos itself. Even the smallest calculations carry weight. A fractional misalignment in thrust, a minor misdistribution of fuel, multiplies across decades of travel, threatening to render the mission impossible. The universe does not forgive error at this scale. Precision is survival. Energy here is not just immense, it is uncompromising, a reminder that every star, every particle, every equation obeys immutable law. Ambition must contend with reality, no matter how brilliant imagination may be. The Great Energy Barrier reframes time and perception. While travelers might experience months or years, the universe outside flows relentlessly, indifferent to their motion. Energy, mass, acceleration, and relativistic effects intertwine into a single, awe-inspiring constraint. To calculate it, to even imagine it, is to glimpse the magnitude of the cosmos and recognize that every star hides energy beyond comprehension. TRAPPIST-1e's distance is more than spatial. It is arithmetic, a measure of impossibility and aspiration. To contemplate it is to recognize the vastness of the universe, the limits of power, and the extraordinary scale of ambition required to cross the void. In that impossibility lies wonder, a quiet testament to how immense, precise, and unyielding the cosmos truly is. We can photograph exoplanets, read their atmospheres, sense their chemistry. But the gulf between seeing and touching is a canyon measured in centuries. From Earth, telescopes capture faint glimmers of light. Filters and spectrometers reveal chemical signatures, and intricate models trace winds, temperatures, and the potential for life. Yet every discovery exists at a distance so vast that it remains abstract, a map of shadows and spectra, not a landscape we can traverse. We know, but we cannot inhabit. We observe, but we cannot inhale the air, taste the water, or feel the pull of gravity beneath our feet. Imagine scanning a distant planet through a telescope. Light that left its surface decades or centuries ago finally arrives, carrying whispers of its chemistry and climate. You trace clouds forming over oceans, detect methane or oxygen, calculate temperatures, and imagine wind patterns. You understand processes, rhythms, and compositions, but the planet remains untouchable, a ghost of substance, revealing itself only through photons filtered across unimaginable distances. Every measurement is a dialogue with light and matter, yet the tactile, intimate experience of presence remains impossible. Even our most sophisticated probes are constrained. Voyagers, telescopes, and orbiters extend our senses, traveling across millions or billions of kilometers, transmitting data at the speed of light. They reveal seas, deserts, atmospheres, and storms, yet every transmission is delayed, sometimes for years or decades. Every instrument must survive extremes that no human body could endure. Temperature swings, radiation, micrometeoroid impacts. Technology becomes a bridge, fragile and brilliant, allowing us to know, but never fully to be there. The canyon between seeing and touching is not just a measure of distance, it is a measure of time, energy, and patience. Light years stretch our understanding, while human lifespans remain finite. The planets we observe might evolve, shift, or disappear before we can reach them. Civilizations rise and fall while our probes drift through silence. Technology extends our reach, but the universe's scale asserts itself relentlessly, reminding us that knowledge is not the same as experience, and that discovery often exists only in imagination and calculation. Yet within this limitation lies its own poetry. To see a planet, to discern its atmospheric composition, to detect the faint signature of water or methane, is a triumph of intellect and perseverance. It is proof that the mind can transcend immediate surroundings, tracing patterns of light and matter across unthinkable distances. Technology allows humans to commune with worlds we cannot touch, to map invisible forces, and to witness the dynamics of alien skies from afar. Each pixel, each spectrum, each data point is a whisper of a distant reality, a reminder of both fragility and genius. The limits of technology teach humility and wonder. They remind us that the cosmos is vast, that presence and knowledge are distinct, and that curiosity often precedes capability by centuries. To see an exoplanet is to glimpse possibility. To measure a world is to honor patience, and to imagine touching it is to engage in one of the most profound acts of human thought. The canyon between seeing and touching may stretch for generations, yet it is precisely this gulf that fuels exploration, inspires ingenuity, and sustains the quiet, enduring wonder of the universe. Light itself is our only traveler fast enough to bridge the void. Every photon we receive from TRAPPIST-1e is a messenger from the past, carrying whispers of alien landscapes, chemical traces, and the faint glow of a red sun. These particles of energy traverse tens of trillions of kilometers in silence, undisturbed by the emptiness around them, delivering knowledge that has already aged by the time it reaches our instruments. Observing a distant planet is like peering into a history written in light. Each photon, a tiny chronicle of conditions long gone, a record of processes that unfolded centuries before our eyes could perceive them. Imagine collecting these photons with a telescope, their arrival painstakingly slow, yet precise. Each photon, has journeyed through the cosmic dark, unaffected by our impatience, unyielding in its trajectory. Together, billions form an image, revealing patterns of clouds, oceans, and continents, or hints of their existence. In these signals, we read spectra, deducing atmospheric composition, temperature, and even the potential for life. Every pixel is both a revelation and a question. What has changed since the light departed? What might exist now that we cannot yet see? Light carries answers, but it does so with the patient deliberation of the cosmos, never in a rush, never accommodating human desire for immediacy. The patience of light imposes humility. Unlike spacecraft, which require fuel, time, and protection, photons need only the void to travel. They obey the laws of physics perfectly, indifferent to ambition, impatience, or hope. Their constancy is a lesson in endurance. Despite the distances, the dangers, and the cold expanse of space, they arrive exactly as nature intended, bringing information uncorrupted, unaltered, and profoundly reliable. To study them is to engage in a dialogue with the universe itself, listening to its measured responses across time and space. There is a quiet poetry in this cosmic patience. Each photon links observer and observed across unimaginable distances, connecting human curiosity to events and places that exist far beyond our reach. Light transforms the impossible into perception, the unattainable into knowledge. We touch distant worlds not with our hands, but with instruments attuned to these messengers, translating their subtle signals into understanding. In the slow assembly of data, we participate in a form of exploration that is both patient and profound, witnessing the universe on its own temporal terms. Even the faintest glow carries meaning. Red light from TRAPPIST-1e whispers of chemical cycles, temperature gradients, and tidal-locked rhythms. Ultraviolet or infrared photons reveal heat, circulation, and chemical interactions invisible to the human eye. Each is a thread weaving a tapestry of knowledge, binding distant planets to our imagination, reminding us that discovery is not always immediate, but eternal in its unfolding. The patience of light is a meditation on time, distance, and awareness. It reminds us that the universe is vast, that information travels slowly, and that observation itself is a gift requiring patience and reverence. Through light, we touch what we cannot reach, perceive what we cannot enter, and understand what spans epochs. Every photon from TRAPPIST-1e is a quiet testament to endurance, a patient messenger, and an invitation to witness the cosmos as it has always existed, in its own deliberate rhythm. Every mission to Titan, from Cassini to the planned Dragonfly drone, is a rehearsal for something greater, a slow crawl toward the stars. Each spacecraft we send, each instrument we design, is a step into the unknown, a test of ingenuity against the vastness of space. They are not just machines, they are the embodiment of human curiosity, patience, and courage, bridging the impossible distance between our small world and the alien moons and planets that orbit distant suns. Imagine Cassini gliding silently through Saturn's system, its cameras and sensors capturing faint glimmers of Titan's methane seas, ice cliffs, and orange haze. Dragonfly, a rotorcraft designed to leap across dunes and frozen plains, will follow, carrying instruments into places no human foot can tread. Every measurement, every photograph, every sample is a rehearsal, a way to understand extremes of cold, distance, and isolation. These missions prepare us for journeys far beyond the solar system, where challenges multiply and time stretches into centuries. The dreams we launch are both literal and symbolic. Every satellite and probe carries ambition, a yearning to touch worlds we cannot physically reach. Yet they also carry knowledge, hard-earned from failures, recalibrations, and the painstaking translation of theory into practice. Titan becomes a classroom, a proving ground for technologies and strategies that one day might allow humans to survive, or at least send instruments safely across interstellar space. It is here, on a moon of methane and ice, that we learn the patience, precision, and resilience necessary to approach the stars themselves. Even the smallest discoveries ripple outward. Understanding Titan's thick atmosphere informs navigation through distant exoplanetary clouds. Mapping dunes and rivers teaches us how to analyze alien geology from afar. Learning to operate robots in extreme cold guides the design of systems for deep space missions. Every success and failure on Titan is a rehearsal for a future where humanity's reach extends to TRAPPIST-1e, Proxima Centauri, or even farther. Each mission is a quiet affirmation that progress is incremental, cumulative, and boundless only in imagination, not in immediate ability. The emotional resonance of these missions is profound. Watching a rotorcraft land on Titan, or observing data transmitted across billions of kilometers, we confront both our limitations and our aspirations. We realize that exploration is as much about preparation and patience as it is about arrival. Every launch is a story of hope, a conversation between human ingenuity and the universe's immensity. These machines, unfeeling yet purposeful, carry dreams into the void, slowly transforming distant, lifeless worlds into landscapes of wonder, understanding, and potential. The dreams we launch remind us that humanity's journey is not measured solely by speed or distance, but by perseverance and imagination. Titan is a rehearsal stage, a training ground, and a beacon, teaching us that the stars are not unreachable. They are simply a patient audience, waiting for us to learn, adapt, and persist. Every mission is a bridge, from curiosity to possibility, from the known to the unknown, from Earth to the silent, distant worlds that call to the human spirit. Even the idea of a 40-year or 400-year journey changes how we think about purpose. Who begins a voyage they know they'll never see end? The mind struggles with time stretched to the cosmic scale, with distances so vast that the traveler becomes a shadow of themselves, drifting through centuries while the home they knew ages, changes, or vanishes entirely. To imagine interstellar travel is to confront isolation not as hours or days, but as generations, where continuity becomes an abstract concept and survival depends as much on mental resilience as on technology. Consider a ship leaving the solar system, its crew aware that they will experience only a fraction of what unfolds back home. Light years stretch between them and the familiar, carrying only memories, records, and occasional messages delayed decades. Each moment is suffused with anticipation, anxiety, and the profound understanding that they are witnesses to a future they will never fully inhabit. Life aboard such a vessel is governed by rhythms that may seem alien, long periods of routine broken by critical decisions, interspersed with moments of awe as the universe unfolds in slow motion around them. The psychology of distance forces a redefinition of achievement. Reaching a star, observing a planet, or even transmitting knowledge across the void becomes a collective endeavor spanning generations. Purpose is no longer measured by personal triumph, but by contributions to a mission that exceeds any single lifetime. Philosophies must evolve, and societies on board may center around patience, preservation, and foresight. Identity blends with continuity. Individuals exist as part of an enduring chain, a living archive of ambition, endurance, and hope. Even without human passengers, the idea shapes exploration. Probes sent to TRAPPIST-1e or beyond will operate long after their creators are gone. Engineers and scientists design systems that must anticipate failure, environmental hazards, and the unyielding passage of time. Each command, each calculation, is infused with awareness of its eventual separation from those who initiated it. In this sense, distance reshapes intention. The goal is not merely arrival, but the careful cultivation of knowledge and experience that will persist long after the originators are memory. There is also a subtle intimacy in this contemplation. Distance forces reflection on impermanence, on what matters when immediate gratification is impossible. Every light year traveled teaches patience, humility, and the courage to act without expectation of witnessing the outcome. The vastness of space becomes a mirror for the mind, revealing both fragility and resilience. The tension between insignificance and the capacity for monumental ambition. Ultimately, the psychology of distance is a meditation on the human spirit. It challenges us to expand notions of purpose, achievement, and connection. It asks us to imagine generations tethered together by shared vision, to trust in outcomes we may never see, and to embrace a form of exploration that is as much temporal and philosophical as it is physical. In contemplating journeys measured in centuries, we confront the cosmos and ourselves, understanding that the act of striving, reaching, and observing may be the truest legacy of all. Titan might one day host robotic colonies beneath its methane clouds, powered by nuclear hearts and patient algorithms that never sleep. These machines would glide over icy dunes, traverse frozen seas, and descend into methane rivers, exploring a world humans can only imagine firsthand. Each robot is both observer and caretaker, designed to endure extremes that would shatter flesh and bone, tirelessly gathering data, performing experiments, and maintaining habitats in isolation. In this way, the moon becomes alive with motion, intelligence, and purpose. Though not human, it is nonetheless a witness to the alien beauty of a distant world. Imagine a fleet of rotorcraft or autonomous landers scattered across Titan's surface, their sensors scanning horizons of orange haze. Nuclear cores hum steadily beneath the ice, providing warmth and energy to systems designed to operate for decades or even centuries. Algorithms adjust navigation, monitor environmental changes, and adapt to unexpected events with a patience humans cannot match. Every movement, every calculation, every transmitted byte is a bridge between distant minds and the alien landscapes they study. Here, endurance replaces speed, and precision replaces improvisation. The robots exist as extensions of human curiosity, yet operate in harmony with the rhythms of a world that is vast, cold, and indifferent. These robotic colonies will reveal Titan's secrets slowly, deliberately. They may measure tides in seas of liquid methane, analyze the chemistry of organic dunes, and probe the hidden ocean beneath kilometers of ice. They will witness storms that drift without urgency, seasons that shift imperceptibly, and geological processes that unfold over millennia. Data transmitted back to Earth will arrive like whispers from another epoch, offering insight not only into Titan's nature, but into the patience required to understand worlds that evolve on timescales far beyond our own. The future of frozen worlds is also a meditation on adaptability. Life as we know it may not survive here, but intelligence, in mechanical form, thrives. Designs must account for radiation, extreme cold, thick atmosphere, and corrosive methane. Systems must self-repair, reroute, and recalibrate, functioning as persistent observers even in the absence of human guidance. In this, Titan teaches a quiet lesson. Survival and exploration are not necessarily about being alive in the biological sense, but about enduring, processing, and responding to a dynamic environment. There is a strange poetry in the hum of reactors beneath alien clouds. Time passes differently when machines operate continuously, decades folding into centuries. Titan's frozen plains and methane seas become arenas of exploration where patience is the greatest advantage, where curiosity and intelligence persist long after the warmth of the sun has faded. These robotic pioneers are proxies for human imagination, stretching our understanding, presence, and ambition into realms we cannot inhabit physically. Ultimately, the future of frozen worlds reminds us that exploration need not be immediate or human. Titan may remain inaccessible to flesh and blood, yet its mysteries will be uncovered through endurance, calculation, and relentless observation. It is a vision of persistence, a testament to the quiet power of patience, and a meditation on what it means to know a world, slowly, methodically, and with infinite care, across the cold expanse of space and time. Perhaps the first travelers to TRAPPIST-1e won't be human at all, but machines carrying our DNA, our memories, our questions. In this vision, vessels glide silently through the void, their hulls armored against cosmic radiation, their interiors a repository of what we are, what we know, and what we hope to become. They are more than probes, they are time capsules, vessels of potential life, carrying the seeds of future civilizations to a distant world where humans may never set foot. Imagine a ship launched from Earth, accelerated by fusion drives or antimatter engines, entering the endless night of interstellar space. Inside, genetic material rests in cryogenic preservation, while algorithms store the sum of human knowledge, literature, music, mathematics, and philosophy. These machines are patient custodians, programmed to navigate centuries without fatigue, correcting for errors, protecting their precious cargo, and maintaining the conditions necessary for life to awaken upon arrival. They are the first ambassadors of humanity, extending our presence far beyond the limits of biology. The seeds of the long voyage highlight a profound truth. Survival across light years demands detachment from immediacy. Life cannot travel at human speeds. Consciousness cannot endure centuries of isolation. Instead, we entrust our essence to systems designed for endurance, precision, and patience. These vessels become a bridge between imagination and reality, carrying not only molecules of life, but the questions that define us: curiosity, creativity, and the desire to understand a universe far larger than ourselves. Even in the absence of humans, the journey is an act of connection. Each photon reflected, each signal transmitted back to Earth, reminds us of our origins and intentions. The ship's instruments probe the environment of TRAPPIST-1e, detecting atmospheres, tides, and chemical compositions. The data is simultaneously alien and intimate, a mirror of what is possible when human ingenuity transcends physical form. Our descendants, biological or synthetic, may one day emerge from this preserved DNA to inhabit and understand a world we could only imagine. The voyage also reframes the concept of legacy. We are not merely launching vessels, we are projecting ideas, culture, and identity into the void. Every calculation, every piece of hardware, every byte of stored memory is a deliberate act of continuity. The long voyage demands patience and trust in forces beyond our control, acknowledging that the first contact with TRAPPIST-1e may be silent, indirect, and mediated entirely through machines. Yet the potential is profound. The seeds we send could one day blossom into life that carries fragments of humanity across the stars. In this way, interstellar exploration becomes less a story of conquest and more a story of hope. The seeds of the long voyage are metaphors for our ambition and humility. A recognition that the universe is immense, time is vast, and yet possibility persists. Through machines, DNA, and memory, we stretch our presence into the cosmos, planting the first chapters of a story that may unfold long after we ourselves have passed. The journey begins not with footsteps, but with ideas, patience, and the enduring desire to be known in the distant reaches of space. What we can imagine, we can almost build, and that almost defines the tragedy of our age. We stand at the threshold of infinity, able to trace the outlines of distant worlds, calculate their climates, and simulate alien ecosystems, yet unable to step through. Our minds stretch across light years with dreams of travel, exploration, and discovery. But our bodies, our technology, and our lifespans are anchored to a tiny pale dot in the void. The gulf between possibility and realization is measured not in imagination, but in physics, time, and patience. Imagine standing on a quiet night, gazing at the faint glow of distant stars. Each point of light represents potential, worlds we might reach, civilizations we might touch, life we might encounter. Yet the very same stars remind us of limits. The distances are unyielding, the energy requirements unimaginable, the passage of time unforgiving. We can send instruments, calculations, and messages, but never ourselves. The universe is immense, and our desire to traverse it collides with the immensity of space, leaving us suspended in a liminal state, aware of possibility, but unable to inhabit it fully. This loneliness is not emptiness, but a poignant awareness of scale. Every exoplanet catalogued, every spectrum analyzed, every simulation run is a testament to human intellect. yet it is also a reminder of what we cannot yet achieve. We can imagine walking across Titan's dunes or standing beneath the crimson skies of TRAPPIST-1e, but our presence there is deferred, trapped in potential, deferred across decades, centuries, or millennia. Knowledge and imagination stretch farther than the human body can follow, leaving our aspirations hovering in a quiet tension between hope and limitation. Even our most audacious projects are framed by this tension. Robotic explorers, DNA-bearing vessels, and interstellar probes extend our reach. Yet they do so without the warmth of consciousness, without the immediacy of lived experience. They transform almost into action, yet they cannot fully satisfy the yearning to inhabit the worlds we observe. In this sense, the loneliness of the possible is a quiet companion to every act of exploration, a reminder that discovery is often indirect, mediated by light, computation, and time. And yet, there is beauty in this tension. It is the tension that fuels imagination, inspires engineering, and sustains curiosity. The very fact that something is almost achievable invites reflection, planning, and careful striving. We learn patience, humility, and the capacity to delight in observation itself. In contemplating the unreachable, we confront the immensity of the cosmos and the quiet power of the human mind to imagine what cannot yet be realized. The loneliness of the possible is the threshold of aspiration. It teaches us that wonder does not require presence, that knowledge can exist without touch, and that the vast distances separating us from the stars are also invitations to dream, to calculate, and to reach beyond immediate ability. We are poised on the edge of infinity, looking outward with imagination as our bridge, recognizing that even in inaction, even in almost, we participate in the profound dialogue between humanity and the universe. Our longing for Titan and TRAPPIST-1e isn't just curiosity, it's self-reflection. We seek other worlds to understand why this one exists at all. The moon's methane seas, frozen dunes, and dense orange haze, or the distant exoplanet's red twilight and ceaseless winds, become canvases upon which we project questions about life, purpose, and origin. In studying them, we are simultaneously observing the cosmos and holding a mirror to ourselves, asking not only what is out there, but why we are here to witness it. Imagine tracing Titan's dark rivers from a spacecraft, the patterns echoing, in strange coincidence, the rivers and valleys of Earth. Or mapping the twilight zones of TRAPPIST-1e, where eternal day meets endless night, and pondering the fragile equilibrium that allows climates, seas, and possibly life to persist. Each observation is a reflection of what makes our own planet habitable, the delicate balance of atmosphere, temperature, chemistry, and motion. By seeking the other, we illuminate the particular, our Earth, our biology, and the extraordinary circumstances that allow us to ponder the universe at all. The mirror is not only scientific but emotional. When we study these alien worlds, we confront our own limitations and potentials. Titan's frozen landscapes remind us of endurance, patience, and adaptation. TRAPPIST-1e's relentless twilight challenges our notions of time, day, and night. Their extremes highlight the grace of the familiar and the improbability of life's flourishing here. We see our vulnerability reflected in their harsh climates and our ingenuity mirrored in the technologies we deploy to understand them. This reflection extends to philosophy. The cosmos, vast and indifferent, challenges our sense of centrality. Observing distant planets reminds us that existence is not guaranteed, that habitability is rare, and that intelligence, ours, is a fragile anomaly. The mirror of other worlds encourages humility, empathy, and wonder, inviting us to appreciate our place without arrogance. Our curiosity becomes a lens through which we examine both the universe and the human condition. Even the act of observation is self-reflective. Every spectrum analyzed, every light curve interpreted, every signal decoded is a testimony to our desire to understand, to make sense of the seemingly incomprehensible. The universe shows us patterns, cycles, and structures, and in deciphering them, we measure our capacity for comprehension. Titan and TRAPPIST-1e are not just destinations, they are instruments of introspection, teaching us about resilience, possibility, and the delicate factors that allow planets and life itself to exist. Ultimately, the universe as a mirror reminds us that exploration is inseparable from reflection. Our longing to reach, measure, and understand distant worlds is inseparable from the desire to understand ourselves. In every cloud of methane, every red horizon, every distant photon, we see echoes of Earth, of humanity, and of the improbable conditions that made consciousness possible. The cosmos is vast, silent, and ancient, but in its alien beauty, we find a reflection of our own questions, our own fragility, and our own awe. The reason it's impossible to go is that it reminds us what possible truly means. Distance, time, and energy form barriers not merely of physics, but of perspective. To consider traveling to Titan, or to TRAPPIST-1e, is to confront the immensity of the cosmos and the limits of human capability. These obstacles are not punishments, they are lessons. Each unbridgeable mile, each century of travel, each quantum of energy beyond reach, is the universe teaching us patience, humility, and the quiet measure of our own aspirations. Imagine standing on Earth, eyes fixed on a distant red dot or a moon shrouded in amber haze. You can calculate its orbit, model its atmosphere, imagine its seas and storms, but to step onto its surface is beyond current possibility. The impossible is a mirror, showing us the magnitude of what exists outside our grasp. It reframes our ambitions, emphasizing that imagination, strategy, and endurance are just as important as speed, strength, or technology. Every boundary the universe imposes is a subtle lesson in what it means to strive responsibly, to dream deliberately, and to value the processes of learning over the immediacy of arrival. This impossibility also highlights the elegance of natural law. Energy, gravity, radiation, and distance are not enemies. They are the rhythm of reality itself. They define the parameters within which exploration and innovation must occur. Recognizing the impossibility of instant or human-scale interstellar travel fosters creativity and humility. It encourages us to invent solutions that honor these constraints: autonomous explorers, long-duration robotic missions, preservation of DNA, and patient study of light that has traveled centuries. In accepting the impossible, we redefine what possible really entails. Ingenuity, foresight, and endurance across scales that dwarf a single lifetime. The meaning of the impossible stretches beyond science and technology. It touches the psyche. It teaches reflection, patience, and the capacity to find wonder, even when direct experience is denied. To observe Titan from millions of kilometers away, or to receive faint photons from TRAPPIST-1e after decades of travel, is to engage with the universe in a way that transcends physical presence. We participate in a cosmic dialogue, responding to distant signals with curiosity, calculation, and reverence. The impossible becomes a teacher, not a limitation, an invitation to expand perception and ambition without demanding immediate gratification. There is also a quiet comfort in this lesson. The universe does not yield to impatience. It reminds us that existence itself is a balance of energy, time, and space. By grappling with the impossible, we cultivate virtues that are both practical and philosophical: patience in action, humility in knowledge, and awe in contemplation. We learn that striving across the void is not just about reaching new worlds, it is about refining ourselves, our understanding, and our place in the cosmos. Ultimately, the meaning of the impossible is a meditation on scale, endurance, and wonder. Distance is not a wall to be broken, but a teacher to be observed. In the impossibility of immediate exploration, we learn what it truly means to be human, capable of imagining the distant, prepared to endure the long, and inspired by the infinite. The universe, in its vast silence, imparts one of its most profound lessons. That possibility is measured not in arrival, but in the patient courage to strive. For now, we stay here, beneath one sun, dreaming of others. Titan drifts silently in its distant orbit. TRAPPIST-1e glows faintly in a red twilight we can barely perceive. Between them and us lies a vast, almost unimaginable emptiness. Yet our thoughts, our machines, and our light cross that distance in ways the body cannot. Every signal we send, every question we ask, every observation we record is already halfway there, bridging the gulf with patience, precision, and intent. The journey is not measured solely in kilometers or years, it is measured in the persistence of curiosity and the courage to imagine. Imagine photons leaving Earth, carrying the signature of our instruments, our probes, our questions, traveling at the speed of light toward distant worlds. They move with unwavering fidelity, indifferent to obstacles, yet guided by our design, our desire, our hope. In a sense, these signals are the first travelers, ambassadors of human thought, mapping the distance between now and what might someday be. And while our bodies remain bound to one pale sun, these messengers venture ahead, carrying fragments of our consciousness, our ingenuity, and our longing. The journey that still awaits is as much inward as outward. Each calculation, every simulation, every transmitted byte is an exploration of patience, endurance, and imagination. We are learning to think on scales that exceed human lifespans, to design missions that unfold over decades or centuries, to cultivate understanding that may outlast our presence. We recognize that presence is not always necessary to influence or observe. Influence can ripple forward through time, through light, and through the careful stewardship of knowledge. Yet the journey is also a meditation on wonder. Standing beneath our sun, we contemplate distant methane seas, crimson skies, and frozen oceans that lie beyond our reach. The immensity of space humbles us, but it also inspires. It reminds us that exploration is not merely about arrival, but about awareness, the ability to perceive, calculate, and imagine realities that exist on a scale far beyond the immediate. In every data point, in every photon collected, the universe whispers its story, and in listening, we participate in something larger than ourselves. There is a quiet beauty in this deferred journey. The impossibility of instant travel sharpens appreciation, focusing the mind on endurance, creativity, and anticipation. Every robotic mission, every light-year spanning signal, every theoretical map is a rehearsal for the human experience of the cosmos. Even if the moment of physical arrival remains centuries away, the act of striving connects us intimately with the worlds we study, the stars we chart, and the vastness that surrounds us. Ultimately, the journey that still awaits is both promise and reflection. It teaches patience, amplifies imagination, and affirms that exploration is not only measured in steps taken, but in questions asked, signals sent, and dreams nurtured. For now, we remain under our sun, but in every calculation, every photon, and every act of curiosity, we are already on our way, already halfway to the worlds that call across the void, and already participating in the quiet, enduring story of the universe itself. We began tonight beneath two very different skies. The amber haze of Titan, near enough to touch with our instruments but distant enough to test every limit of engineering and endurance, and the dim, patient glow of TRAPPIST-1e, a world whose promise travels on light that takes decades to reach us. We traced the physics that keep us home, the cruel arithmetic of distance and fuel, the heat of interstellar motion, the slow tyranny of light time, and the fragile biology that cannot be hurried. We listened to Titan's methane rain and felt the impossibility of reshaping whole atmospheres. We stood at the edge of TRAPPIST-1e's twilight and understood that some journeys are measured in generations, not in single lives. And yet, in that catalogue of impossible, we found something softer, reason to wonder, and the steady comfort of our own patience. The obstacles do not erase beauty, they reveal it. They show us how precious and delicate this world is, and how remarkable our tools become when guided by curiosity. They remind us that exploration need not always be footsteps on foreign soil. Sometimes it is the slow enlargement of knowing, a photon-by-photon conversation across the dark. As you drift now, let gratitude settle in for the warmth of our sun, for the minds that build telescopes and drones, for the tiny, stubborn life that made us ask these questions in the first place. Hold that thankfulness like a soft cloak against the cold vastness the universe presents. If your thoughts wander toward alien seas or red sunsets, let them be gentle voyages, impossible only in the way a dream can be, stretching the heart without breaking it. Sleep into the knowledge that we are citizens of a curious age, that our questions are seeds, and that patience will carry them into bloom long after this night. Good night. Let the slow, patient universe keep watch while you rest.